Hello everyone, I hope you're doing good and staying safe. I welcome you all to the day 2 of this training program series on C++ programming language. I hope my audio is fine and the screen is clearly visible. If you guys are facing any sort of issues, let us know in the comment section below and we will try to resolve it as soon as possible. Now, in our previous session on this training program series on C++, we have covered some major basics and fundamentals of C++ language, wherein we have covered topics like introduction to C++, why we use it, how C++ came into existence, and why it is an extension to C programming language. And then we have covered some major topics like C++ functions, recursive functions, if-else statements, and so on. So if you guys haven't checked out the part 1 of this training session on C++, I would highly recommend you to watch it on our channel. So make sure you check that out. So in today's session, we'll be discussing some more intermediate level topics of C++. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel SimpliCode to stay updated with all the latest tech content. And hit that bell icon to never miss an update from us. So without any further ado, let's get started. Alright, let us discuss the agenda for today's session. We'll start this tutorial by understanding what is memory management in C++. Up next, we'll understand what are classes and why we use them in C++. And then we'll have a thorough discussion about object-oriented programming in C++. And up next, we'll be discussing all about the operator overloading function in C++. And then we'll look into C++ vectors and other important topics like C++ STL and finally C++ enumeration. I hope I made myself clear with the agenda for today's session. So without any further delay, let us dive straight into today's topic. Over to our training expert.
In today's session, we are going to learn about C++ memory management. So let's go ahead and have a look at what's in it for us. First is, what is memory management? Then we will understand why we need memory management in C++. Then we will learn memory allocation and deallocation in C++ using new operator and delete operator. And at last, we will understand the advantages of new operator in C++. So without further ado, let's get started. What is memory management? Memory management can be defined as a process in which management of a computer's memory occurs. For example, assigning memory to programs, variables, etc. in such a way that it doesn't affect the overall performance. Sometimes the computer's data can range up to terabytes. So efficient use of memory is necessary so that we can minimize the memory wastage and boost up the performance. Now, let's understand why we need memory management in C++. Memory management is required so that there will be no wastage of memory and to make sure that allocation takes place efficiently. During the declaration of an array, there are times when the correct memory is not determined until runtime. And to avoid such cases, we usually declare array of maximum size. And because of this maximum size, some memory remains unused. For example, let us suppose we have declared an array of size 30. And after declaring the array, it turns out that we only need space of 10 size. So, the rest of the space is of no use, or we can say it will get wasted. To avoid such cases, we use memory allocation. So, let's understand memory allocation and deallocation in C++. Other programming languages like Java, Python, etc., they don't need to allocate memory dynamically. In C language, we use the malloc or calloc functions to allocate the memory dynamically at runtime. And these functions are also supported by C++. But in C++, allocation and deallocation is done manually. In C++, there are two operators that are used for the allocation and deallocation of memory. That is new operator and delete operator. So, let's understand this new operator in C++. The new operator in C++ is used for the dynamic memory allocation. It is used to allocate the memory at runtime. The general syntax of new operator is pointer variable, which is the name of the pointer, equal to new, which is a keyword, and data type, is the type of the pointer. The syntax for arrays is almost the same, but after the data type, we have to write the size inside the brackets, which specifies the number of elements in an array. And here in the example, we first of all are declaring a pointer ptr of int data type. After that, we are dynamically allocating the memory using new keyword, and at last we are assigning the value 75 to the allocated memory. Coming to the delete operator. The delete operator in C++ is used for the deallocation of memory. When we no longer need to use the variable, that means the memory is no longer required, then we have to deallocate or release the memory using the delete operator. Syntax for delete operator is delete keyword with the name of the pointer variable. The syntax for arrays is delete keyword following the empty brackets and then name of pointer variable. As we can see in the example, once the printing of value is done, we have deallocated the memory using the delete operator. Moving on to the advantages of new operator. The new operator and delete operator can be overloaded unlike the malloc function. Next is, a return type of the new operator is of the same type for which the memory was allocated. We don't need to use the typecasting. Third is, the new operator automatically computes the size of data object. We don't need to use the size of operator. Next is, new operator in C++ allows us to initialize object while creating memory space for them. So these were some advantages of the new operator. So now let's move on to our code editor, that is VS Code, to do some examples on the new operator and delete operator. Here we will do an example using new and delete operator in C++ that will allocate the memory location for 3 values and find their average. So first of all, let's create a file and name this file as mm1.cpp. mm means memory management. So now first of all we'll include the header files, #include iostream, now using namespace standard, now we'll start with int main. Okay, so first of all we'll create 3 pointer variables. So we'll start int star ptr1, int star ptr2. We are creating 3 pointer variables because we have to find the sum of 3 variables, so that is why we have to create 3 pointers also. And now we have to store the sum of 3 variables into some another variable, so now we'll create the variable average. Okay, now we will allocate the memory dynamically using the new keyword. So we'll write ptr1 equals new int, which is the data type. Same we will do for ptr2 equals new keyword int. Here we are allocating the memory dynamically with the help of new keyword. New int. Sorry, m is there. Now we will print the value that is stored in the memory. But before doing that, as we have allocated the memory, so now we will take the input from the users of those 3 variables of which we have to find the average of. So we'll display enter first number. After displaying this, we'll take the input from the user, we'll write C in, and using the dereference operator, we'll write ptr1. Here we are taking the input from the user for the first memory location. Now we'll take the input of the second number from the user. For that we have to print the message again. Enter the second number. Yeah. Now we'll take the input using the dereference operator with the pointer. Now same goes for the third one. Enter the third number. Dereference operator ptr3. As we have taken all the three numbers from the user, now all we have to do is to find the average of these three numbers, as we know that dereference operator will point to the variable. So that is how we'll get the access for the variable. Now we'll write the variable avg, that is average. We know that dereference operator will display the value that is pointer pointing at. So we are actually adding the values ptr1 plus dereference operator ptr2 plus dereference operator ptr3 divided by 3. This is how we can find the average. After that, all we have to do is to print the average. So we'll write average is avg, that is the variable, as the result is getting stored in this variable avg. So we'll print that variable, and once everything is done, once the printing is, then we have to deallocate the memory, and we will deallocate the memory by writing delete ptr1. We have to do this for all of these three pointers. Delete ptr2, because we have allocated the memory for all of these three pointers, so that is why we have to deallocate for each one of them. Okay, now everything is done, and let's try to run this. Here we can see enter the first number. So let's say 5. We have to find the average of three numbers, so we'll select the easy number to check whether it is right or wrong. Then we'll write 5 again. Now we'll write 2. As we know that 5 plus 5 equals 10 plus 2 equals 12, and the average of 12 is 4. Yeah, 3 4s are 12. So this is the correct output. So first of all, we have allocated the memory over here dynamically, then we have deallocated the memory using delete ptr1, ptr2 and ptr3. So this is how it's done. So let's do one another example. Let's name this as mm2.cpp. Okay, we'll write mm4.cpp. I think 2 and 3 are already taken, so we'll start with hash include iostream. Hash include iostream. Then we'll write using namespace standard. So in this question, we'll simply enter the elements of the array, and then we will display those elements. But we will use new operator and delete operator in this question. So let's start. First of all, we'll write int main. Now inside int main, first of all we'll write the variable size. We have declared the variable size, and this variable size is the size of the array which we will take as an input from the user. So first of all we'll display enter the size, enter the size. Now we'll take the input size. After that we will declare a pointer variable ptr. Alright, now here we will allocate the memory for the complete array. So we'll write ptr new keyword int, which is the data type, and here size. Okay, here we are allocating the memory for the complete array of size that we will enter. Okay, now we will display the message saying that enter the elements. As we have allocated the memory, now all we have to do is to enter the elements. We'll use a for loop. So we'll start with int I equals 0, I less than size, I plus plus. Now we'll write element, and after this we'll take the input from the user for the elements of the array. So we'll write cin. Now just like arrays, we can do it for the pointer as well. We can write ptr, and just like arrays, inside the bracket I, and we can do it for the output as well. So here we are taking the input of the elements from the users. Now we have to display those elements. So for that, first of all we'll display a message, elements that you have entered. Now we'll use for loop again. Int I equals 0, I less than size, I plus plus. Now we'll print those elements. So first of all we'll write element now ptr, like just we did earlier, ptri, and end line, so that the output looks good. Now everything is done. We have allocated the memory, then we have taken the input from the user and displayed the output. Now all we have to do is to delete the operator. So we'll write delete, then empty brackets, ptr. Alright, now everything is done. We have allocated the memory, and here we are deleting the allocated memory. Okay, now let's try to run this. Here we can see enter the size, let's say 4. Now enter the elements 3, 6, 5, 7, and here is the output, elements that you have entered 3, 6, 5, 7. That is right, but it is not looking good. Let's use /n over here, and now let's again try to run this. Enter the size 4. Now 2, 4, 7, 9. Here is the space between them. Now it is looking good. Enter elements that you have entered are 2, 4, 7, 9. So this is how it's done. We have allocated the memory to an array of size variable. Then we have entered the elements. Then we have displayed those elements, and at last we have deallocated the memory using delete operator. So these were few examples on memory management, C++ memory management. You can try some more examples on them. In this video, we will learn about classes in C++. First, we will learn about why do we need classes. Then we will learn what is a class. Then we'll go through access modifiers and object of a class. After that, member functions. And at last, we will learn about constructors and destructors. So first is, why do we need classes? To understand this, we need to know that C++ is an object-oriented language, and it also introduces the concept of real-world entities. So in order to describe the real-world entities, we need two things, that is characteristics and functions. And a class is a mechanism of binding these two methods together in a single unit. Also, class has its own members like functions, variables, constructors, destructors, etc., which are commonly used in C++. And class has an important role in the concept of inheritance as well. Now, let's understand what is a class. Classes are one of the most important features of C++ that leads to object-oriented programming. It represents the set of properties that are common among all the objects of same type. A class basically represents a group of similar objects which holds its own data members and member function together. And this is the basic syntax of a class. First is class keyword, which is used to create class. Then after that we will write the name of the class. Then inside the name of the class there is access specifier that can be private, public or protected. After that there is data members, that is the variables, and then the member functions, and also class body must be surrounded with braces. Now let's discuss access modifiers. It basically grants permission or set the restriction for data members of the class. Access modifiers in a class are used to provide accessibility to the class member. For example, in a school, teachers are allowed to see the question papers before the exams, but the students are not allowed to do so. Anyone other than teachers cannot access those questions. Now, we can relate these teachers to data members of class which have access, and students are outside functions that do not have the access. So there are three types of access modifiers: private, public and protected. Private members can only be accessed from within the class. That means outside data members and member functions cannot access it. Public, as the name suggests, it can be accessed from within the class and from outside the class as well. Protected members can be accessed from within the class but cannot be accessed from outside the class. But with the help of friend function, it can be accessed from outside the class as well. Now let's learn about object of a class. An object is an instance of a class. It is a real-world entity that contains state and behavior. When we create an object of a class, then the memory is allocated, and no memory allocation occurs when class is defined. And we can create as many objects of a class as we need. In this example, state is the class and st is the object name or reference variable. So this is how an object is created. Now coming to member functions. Member functions are also known as methods. These are as much as part of the class as the member variables. These member functions can be invoked by sending messages through an instance of a class with the help of dot operator. For example, if the name of the object is obj and we want to access a function named sum, then it will be obj.sum. Here obj is the name of the object and sum is the name of the function. What is a constructor in C++? In C++, constructors are special functions that are different from normal functions. They are used to initialize objects of a class. Whenever an object is created, the constructor is invoked or called automatically. Even if we do not create a constructor, the compiler automatically creates a default constructor. Now, let's move to the declaration of the constructor. Constructors are the member functions of a class that has the same name as that of the class and it doesn't have any return type. A constructor can be defined inside the class and outside the class as well using the scope resolution operator. The syntax of a constructor is as mentioned. Inside the class cons, we can see there is a constructor which has the same name as that of class, that is cons, and we can initialize variables inside it. This constructor will be invoked automatically when the object is created. Now let's understand how the constructor is different from functions. There are some differences between constructors and functions. So the first is constructor doesn't have a return type unlike function which has a return type. Next is the name of the constructor must be the same as that of the class and it is not so in case of function. Third is whenever an object is created then a constructor is invoked. And the last one is function can be a virtual function but it is not so in case of constructors. So these are some differences between constructor and a function. Now coming to types of constructors. There are actually three types of constructors in C++. That is default constructor, parameterized constructor and a copy constructor. So let's start with the default constructor. A default constructor is a constructor that doesn't have any arguments inside it. It can either be declared explicitly or can be generated automatically, which means even if we do not define the constructor, then also it is generated by the compiler. For example, here cons is the default constructor. In this case, the name of the class would have been cons. That is why the name of the constructor is cons. Now, coming to the parameterized constructor. A parameterized constructor is similar to that of the default constructor. The only difference is we can pass the arguments to the parameterized constructor. The constructor can be overloaded and also be used to initialize elements. Here is an example of the parameterized constructor. Cons is the name of the constructor and n1 and 2 are the parameters of the constructor. Now, coming to the copy constructor. A copy constructor is a type of constructor which initializes an object using another object of the class. In this constructor, properties of one object is copied to another object. This copy constructor is invoked when an object is passed as a parameter. If a class has pointers or there is some dynamic memory allocation, then it is necessary to have a copy constructor. Its syntax is as follows. Here cons is the name of the constructor and ampersand obj is the reference of the object. As we have understood all of these three constructors, so let's go ahead to our next topic, that is constructor overloading. Like functions, constructor can also be overloaded and it is pretty much the same as function overloading. The constructor must have the same names and the difference in the number or the type of arguments will decide which constructor should be called. Here in the example, we can see two constructors with the same names as that of the class are being overloaded. Here the difference in the number of parameters will determine which constructor will be called. Now coming to the last topic, that is destructors in C++. Just like the constructor, the destructor is also a special function which deletes or destructs the object as soon as the object goes out of scope. It basically deallocates the memory that has been assigned to the variables. The name of the destructor is same as that of the class name with a tilde sign. The destructor doesn't have a return type and it also doesn't take any arguments. And here is the syntax of the destructor. Now here we will make a new file and let's name this file as class.cpp. Now here we will do a program in which we will make a class, and inside that class we will make some functions, and with the help of objects of that class we will call those functions. So let's start. First of all, we'll mention the header files #include iostream. Now using namespace standard. Now let's make a class, and with a class keyword, and name this class as, let's say, franchise. Now here don't forget to mention the semicolon. Now here we will write the access modifier, that is public Now we'll mention those functions. Let's say void, let's name this function as KFC. Now inside this function we will print something like, let's say, we have the best chicken. After this we'll write endl. Now we'll make another function named Burger King. As we know that these two are famous franchise, so that is why we have put this under class for franchise. Now let's print here we have the best burgers. Now we'll try to print these two functions with the help of objects that are made from the class franchise. So what we'll do is we'll write int main. After the franchise class we'll write int main, and inside this class we'll make an object of class franchise. Franchise is the class name, fran is the object name. Now all we have to do is the calling. We'll call the function KFC and we'll call the function Burger King with the help of fran object. So let's do this. Fran dot operator KFC, that is the function name. After that we'll write fran dot Burger King, return 0. Now let's try to run this one. Here it is. Actually I have run it twice, so that is why it is getting printed twice. We have the best chicken, we have the best burgers, that is what we want to print. First here friend.kfc, call this void KFC inside this class franchise. After that friend.burgerking, call this function Burger King. So that is why they have printed serial wise. We have the best chicken, we have the best burgers. After this we'll do another example. So let's do this. First of all we'll name this file class2.cpp. Okay, I think it already exists. We have to name it something else. 3. Okay, now we will write the header files. Hash include iostream. Now using namespace standard. In this example, we will try to access a private variable, as we know that it can only be accessed from within the class, but it can be done with the help of setter-getter methods. So let's start. First of all, we'll write int main. Now we'll make an object. For that we have to write the class name, which is billboard. We'll make this class afterwards. First of all, we'll write the class name. After that, we'll write object. Let's name the object bill. Billboard is class name, bill is the object name. Now we will call a particular method or a function which we call setter method. So we'll write bill dot, we'll name that setter method as set title. Basically this function will access or assign the value to the private variable which we were talking about. So we'll write here, let's say top 5 songs of 2020. We want this title to be written on the billboard. Now we'll write the getter method. Basically the setter method or set title method will set or assign the value of to the private variable, and get method or get title method will return that value from there. So we'll write bill dot get title. Now because we want to print it, so that is why we'll write it in cout. Okay, now after that we'll write return 0. Now we will make the class billboard. Class keyword billboard. After that bracket starts. Now we will write private because we want the variable to private. So the data type string and the variable is title. Now this variable is private and we want to assign the value to this variable, which is not possible because they are not of the same class, but we will do that with the help of setter getter method. So let's do that. Now we will write public because we want our functions to be public. Now void, that is the data type, set title, and inside the bracket we'll write the variable. Now this method is taking this parameter x, so we'll assign this parameter x to the private variable. Let's do that. Title, that is the private variable, x. Now we will write another method named getTitle. There are no parentheses in getTitle method because this method is only returning the value. So we'll write return title. Now getTitle function or method is returning the value of private variable title. So here what happening is, here the function setTitle, which is public, is taking a parameter x and is assigning to the title variable. So the message will get assigned to the title variable. Now getTitle function is returning the value of private variable title, which is getting called in the main function. One more thing, we forgot to put semicolon over here, and we getTitle cannot be void because it is returning. It would be string because it is returning some value. Now, so basically build.setTitle in the main function will set the value or assign the value to the private variable, and build.getTitle will return the value of that private variable, which will get printed. So now let's try to run this. Top 5 songs of 2020. Here we can see it is getting printed. So this is how we can do that. We can access the private variable using setter and getter method. Now let's do another example. Let's name this as class 4.cpp. Now here we will do the same example, but we will do it with the help of constructors. So let's continue. First of all, we'll write hash include iostream. After that, using namespace standard. Now here first of all we'll write int main. Now we'll name the class, we'll write the name of the class, that is billboard, and we'll make the object of it as we have done previously, like bill. Now we'll make a constructor of this object and we'll pass the parameters. We'll pass the string as top 3 songs of 2020. As we are passing this string to the constructor, that means the constructor is parameterized constructor. And now we'll write bill dot get title. Here we are writing this because this function is returning the value of private variable title, so that is why we have to write it. And we'll print it actually cout. Return 0. Now let's do the other thing. As we have done previously, we'll write class billboard. We are making this class, and inside this class we are making the variable private. String title is private. Now we'll write public access modifier. Now here we will write the constructor in which we were passing the string from the main function. So we'll write the name of the constructor. As we all know, the name of the constructor is same as that of the class, so it would be billboard, and the parameter is b. that parameters which we are passing from the main function is getting stored in B. Now inside this constructor we'll call the method setTitle. So we'll write setTitle. We are passing the same string to the setTitle method. Now we'll make this method setTitle. We'll write void setTitle string A. So actually what is happening, we have passed a string named top 3 songs of 2020 to the constructor. The constructor is further calling to the method or function named setTitle and is passing that string to the same function. Now that function is setTitle, and now we will assign that string to the private variable title. So let's write title equals A. A is that string. Now as we have done previously, we'll write void get title. Now get title function is used for returning the value of private variable, as we know. So we'll write string actually. String get title return title. Semicolon. Now let's try to run it. I think something is wrong. Here capital S we have written. Let's make it correct. Now let's try to run again. Here we can see top 3 songs of 2020. So this is how we can print with the help of constructor. This was the same example as that of the previous one, but to understand constructors we have done this with the help of constructors and we get the right output. So after this we'll do the example of destructors. Okay, let's name this as class 6.cpp. Now let's write the header files. Hash include iostream using namespace standard. Now we'll start with int main. So first of all we will write the class name, that is Gambit. To access the class we need to have an instance or object of class. Here the name of the object is Gam. After this we will call a function display, so we will write gam.display. Return 0. Now let me tell you what is happening. So as we declared this object, constructor will be called, that is Gambit, and the message inside the constructor will be printed. After the constructor gets completed we will return back to the main. Now we have gam.display, which is used to call display function inside the Gambit class. So after this we will write the class. Let's make it class keyword gambit. Now we'll write public access modifier. Now we'll write the constructor, and inside the constructor we'll display the message. We'll write hello there, I'm a constructor, I'm in constructor. And inside the destructor we will print the message just to indicate that we are in the destructor. Hello there, I am in destructor. Semicolon. But before that we have to write the function display also. So we'll write void display, and we'll print the message, let's say hello. And L. Now let's try to understand this again. As the object is declared, constructor will be called, that is gambit, and the message inside the constructor will be printed. After the constructor gets completed, we will return back to the main. Now we have gam.display, which is used to call display function inside the gambit class. So hello will be printed. Now as we can see, the program has finished the execution. Now the destructor will be called and hello I am destructor will be printed. As we know, destructor destroys the object as the scope of the object ends. So after the scope of the object ends, hello I am in destructor gets printed in the last. So now let's try to run this. Here we can see hello there, I am in constructor, then hello is printed, then hello there, I am in destructor is printed. As we have thought, destructor is getting printed in the last because as we know that when the scope ends, the destructor is called. So these were some basic examples of classes in C++. In order to understand them better, you must practice some more examples on them. In today's session, we will learn why we need OOPS. Then what is object-oriented programming? Then we will discuss the difference between OOPS and procedural programming. Then we'll go through basic concepts of OOPS, and at last we will learn about the benefits of OOPS. There were some limitations in earlier approaches to programming, and OOPS help to fill those gaps. In object-oriented programming, it is easy to maintain the code with the help of classes and objects. And with the help of inheritance, there is code reusability. That is, we don't have to write the same code again and again, which increases the simplicity of the program. Now, let's understand what is object-oriented programming. Object-oriented programming is a programming pattern where the programs are structured around objects rather than logic and functions. In other words, OOP basically focus on objects that are required to be manipulated instead of logic. For example, let us suppose we have made blueprint of a mall. Then that blueprint will be a plan that explains what properties the mall should have and how it should look like, etc. But it is just a blueprint of the mall. We cannot go inside it physically as of now. Now the constructors will go through the blueprint and they will construct the mall, and they can make as many malls as they want with the help of that blueprint, and each mall can have its own different shops and showrooms. In this case, blueprint is the class, the mall is the object, and the shops and showrooms inside the malls are data stored in the object's properties. And these are some basic concepts of OOPS. First is classes, then objects, then data abstraction and encapsulation, then there is inheritance, polymorphism, dynamic binding, and message passing. We will learn about these concepts later. First, we will discuss the difference between OOPS versus procedural programming. Procedural programming follows top-down approach. Here, top-down approach means fragmenting a bigger complication into smaller chunks. OOPS follows bottom-up approach, and bottom-up approach means piecing together smaller tasks to give rise to complex tasks. In procedural programming, overloading is not possible. In OOPS, overloading can be done. In procedural-oriented programming, there are no access specifiers. In OOP, they have access specifiers like private, protected, public. Procedural-oriented programming is less secure. OOPS is more secure because of the concepts like abstraction and encapsulation, which are used for data hiding. Now, let's learn the basic concepts of OOPS. First is class. Class can be defined as collection of objects. It is a logical entity. Then there is object. It is defined as an entity that has state and behavior, or in other words, anything that exists physically in the world is called an object. Inheritance can be defined as when one object acquires properties and behavior from its parent class. It provides code usability. Polymorphism. Polymorphism is a combination of two words, poly, which means many, and morphs, which means forms. It is basically an ability to exist in more than one form. Next is abstraction. Hiding the internal details and showing the functionality to the user is called abstraction. Then encapsulation. Encapsulation is the binding of code and data together into a single unit. Dynamic binding. Dynamic binding is the method call at runtime that means which code will execute is unknown until the program runs. Then there is message passing. It is basically a communication that exists between the objects. As we have gone through some concepts of OOPS, now let's discuss some benefits of OOPS. In OOPS, code can easily be reused with the help of inheritance and object. We don't need to write the same code over and over. Second is, with the help of abstraction and encapsulation, certain parts of program can be hidden, and it helps to make a secure system. Third is, maintaining and modification of code is easy in object-oriented programming. Now, to do some examples on concepts of OOPS, let's move on to a code editor, that is VS Code. Now here we will do a program of inheritance in which we will make a parent class and a child class, and we will call the attributes using object of child class. So let's get started. First of all, let's name the file. oop.cpp. Okay, so first of all we'll add the header files hash include iostream. Now adding namespace standard. Now we will write int main. So we want to create the object of child class. So first of all we'll write the name of class child, that is child. Let's put C capital child, and now the name of the object ch. So now we will call the attributes using this object. So we'll write first of all display it. So we'll write cout ch dot name 1, which is the attribute. We will declare it later. So basically we want to write both the names of both the classes together, so that is why we are doing like this. We'll write name2. Name1 will be the attribute of the parent class and name2 will be the attribute of child class. So after that we'll write return 0. Now we'll make the parent class and the child class. So first of all, let's write class parent. We'll name it as parent. Then we'll write public access specifier. String is the data type. Name1. Let's write Harley. Okay, now it is mandatory to write the semicolon at the end of the class. Now we'll write the derived class, that is child. We will write the colon symbol, then we will write public name of the parent class, that is parent. So here we are writing the child class is derived from the parent class. Now within the bracket we'll write public, then string the data type, name2. We'll write Davidson. It's a popular bike brand, Harley Davidson. So now we'll write the semicolon over here. Now we'll try to run this. As you can see, Harley Davidson. Here Harley is from the parent class and Davidson is from the child class. So as we can see that we are calling from the object of child class and still we are able to access the attribute of parent class. So this shows that the child class inherits attributes or properties from the parent class. Now as we have done one example of inheritance, so now let's do one example of polymorphism also. Let's name it oop1.cpp. First of all, we'll include the header files. --include iostream stream. Now we'll write using namespace standard. After that we'll write int main. Now here we will do an example of polymorphism in which we will make a base class and its derived classes, and inside these classes we will override a function which is common in all of these classes. So let's start. First of all, we'll write the name of the parent class or base class, animal, and we'll make an object A. After that we'll write the name of the child class cheetah and its object name is seal, let's say. Now another derived class dolphin, and we'll name the object as D. Now while making these classes, we'll write a function named speed in all of these classes, inside all of these classes, and now in order to override that function we'll call them. So first of all we'll call it by the object of animal, that is a dot speed. Now c dot speed, this is the object of cheetah class. Now d dot speed. After that we'll write return 0. Now let's make these classes. First of all, we will make the animal class, that is the base class. Animal. Now we'll write the access specifier public. Now we'll write the function void, that is the data type speed. Now we will display a message inside this function. Let's say it displays who is more faster. Who is more faster. Okay, now we'll put a semicolon in the end. Now we will make a derived class, that is dolphin. We'll write class dolphin child of animal class. Okay, so now inside this class we'll write public and we'll make the same function speed. And we'll display a message saying, as this class is of dolphin, so we'll write I'm faster in water. We'll put semicolon. Now we'll make another child class, class cheetah. Okay, C is capital, cheetah. Public animal. Now here we will write public access specifier and we'll write the same function void speed. And over here we'll display a message saying that I am faster on the ground. Semicolon. So now as we can see that a.speed is calling this speed function in animal class, c.speed is calling this cheetah function in cheetah class, and d.speed is calling the dolphin speed function in dolphin class. Okay, so now let's try to run this. Okay, the output is here, but it is not in very good form, so let's put /n in the end. Okay, /n. /n. Okay. Here it is. So first who is faster is displayed, then I'm faster on the ground, then I'm faster in water is displayed. So as we know that first of all we have called the animal class, so that is why who is more faster is displayed. After that we have called the cheetah class and cheetah says that I'm faster on the ground. Then dolphin class, then dolphin says I am faster in water. So here we can see that each of the class have its different implementation for the same function, that is speed, and this is how polymorphism allows us to do a single action in variety of ways. Okay, now let's do one example of abstraction. Let's name it as oop3.cpp. First of all, we'll include the header files. We'll write hash include iostream. Now we'll write the namespace standard using namespace std. Now, as we know, abstraction helps in data hiding. So in this program, we will make a variable named coupon as private, and with the help of setCoupon function, we will try to assign some value to the coupon variable, and after that we will display it. So let's start. First of all, we'll write int main. Now we'll write the name of the class, that is trade fair, and now the name of the object t. Now with the help of this object, we will call a function named setCoupon. I would say coupons, and we will pass 50 as an argument to this function. Now we'll display a message coupon, and after that we will call getCoupon method in order to display the number of coupons. So we'll write t dot get coupons and brackets, done. After that we'll write return 0. Now let's make the class and the functions. So let's start. First of all, we'll write class trade fair. Now we'll write an access specifier private and private. Now we will declare a variable coupon, and as I've already told you, we will make this variable as private, so that is why we have used this access specifier as private. Now after that we will write public access specifier to write a function that is setCoupons. And the parameter is c. As we know that we have passed 50 to this parameter, so now we will write the private variable coupon equals c. So here we are basically assigning the value of c to the coupon, that is we are assigning 50 to coupon variable. Now after that we will make another function and we'll put its data type as int because it is returning something. So we'll write int get coupon and we will return variable coupon. Now as the class ends, we will write semicolon. Now let's try to run this code. There is some error. Okay, we haven't write s over here. Now let's again try to run it. Coupon 50, as I've told you. So here we have assigned 50 to this function, and the variable c is assigning 50 to the variable coupon. Now after that we have used getCoupon function to return the value of coupon, and that is why it is getting displayed over here. So we got our answer, that is coupon 50. And as you can see that in this example we are not allowed to access the variable coupon, but still somehow we have managed to do that with the help of some functions. So this is an example of abstraction, and it helps to increase the security of the program. So these were some basic examples of OOPS in C++. In order to understand it better, we must practice some more examples on it. Today we will learn about C++ inheritance. So without further ado, let's get started. So in this session, we will learn about what is C++ inheritance, why do we use inheritance in C++, then we will understand different modes of inheritance, and after that we will learn about types of inheritance, that is single inheritance, multiple inheritance, multi-level inheritance, and hybrid inheritance in C++. But before we begin, make sure to subscribe to our channel and hit the bell icon to never miss an update. So what is inheritance in C++? Just like a child inherits the behavior and characteristics from his or her parents, similarly, inheritance in C++ is a process in which the derived class acquires all the properties and characteristics from the parent class, that is the base class. Derived class is also known as child class, and base class is also known as parent class. Inheritance is one of the most important features of C++ OOPS, that is object-oriented programming. In inheritance, there are two types of classes. The class which inherits the properties and behavior from the base class is known as derived class, and the class whose properties or characteristics are inherited is called a base class. Now let's understand why we use inheritance in C++. Inheritance is used in C++ because it increases the reusability of the code and it helps in removing the redundancy. To understand it, let's suppose there are two classes, two-wheeler and four-wheeler. Both of the classes contain similar functions like color, brand, and mileage. Now, if we create these classes, we have to create all the three functions in both of the classes. Or in other words, we have to write the same code two times in both of the classes. So instead of writing that code again and again, we can use inheritance and create a parent class named class vehicle. And both of the two-wheeler and the four-wheeler classes will be inherited from this parent or base class. Now with inheritance, we have inherited both the classes from one base class, that is class vehicle. Now we no longer have to write the code again and again, and we can simply write the functions once in the base class, as both of these classes are inherited from the base class vehicle. So as we have understood about inheritance in C++ and why we use inheritance in C++, so now let's go ahead and learn about modes of inheritance. There are three modes of inheritance in C++, that is public mode, protected mode, and private mode of inheritance. So let's start with the public mode. In this mode of inheritance, the public members of base class remains public in derived class, and same goes for the protected members. That means inside the base class, the class members that are public will remain public in the derived class, and similarly protected class members will remain protected in derived class. Now protected mode. In the protected mode, the public and protected members of the base class will become protected in the derived class. That means the class members which are public or protected in the base class will all become protected in the derived class. In the private mode of inheritance, protected and public members of class will become private in the derived class. So now let's go ahead to the types of inheritance. So there are various types of inheritance in C++, that is single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. So let's start with the single inheritance. In this type of inheritance, a single derived class is inherited from the single base class. It allows the derived class to inherit properties and behavior from the parent class. The derived class objects can access the members of the base class, but the base class objects cannot access the members of the derived class. So now let's have a look at the syntax. As we know, this is single inheritance, so there will be only a single derived class and a single base class. And this is how we derive a child class from a parent class. Class keyword, then the name of the derived class, then the colon operator. After that, there is an access modifier with the base class. Now, as we have understood about single inheritance and its syntax, now let's move on to multiple inheritance. Multiple inheritance. When a class inherits from more than one base class or multiple base classes, then it is known as multiple inheritance. It allows us to inherit properties and characteristics from more than one base class. Syntax for multiple inheritance is class keyword with the name of derived class, then the colon operator and access modifier with the name of the base class separated with comma and the name of another base class. Here we have shown only two base classes, but we can make more than two base classes depending upon our requirement. Now, coming to multi-level inheritance. In this type of inheritance, the derived class is inherited from another derived class. That means when a class extends a class that further extends another class is known as multi-level inheritance. For example, if there are three classes A, B, C, and class C is inherited from class B, and class B is inherited from class A, then it can be called as a multi-level inheritance. Syntax of multi-level inheritance is as follows. Base class 2 is derived from base class 1 and the derived class is derived from base class 2. These base class 1, base class 2 and derived class are just the names, not a syntax. You can write whichever name you want with the class. Now let's learn about hierarchical inheritance. In this type of inheritance, more than one class is inherited from a single base class. That is, there would be a single base class and multiple derived classes, which have the properties and features same as that of the base class. As we can see in the figure and in the syntax, the derived class 1 is derived from base class, and similarly derived class 2 and derived class 3 are also derived from the base class. So this was hierarchical inheritance. And our next type of inheritance would be hybrid inheritance. The hybrid inheritance is the combination of more than one type of inheritance, and it can be said that it is a combination of multi-level and hierarchical inheritance. In the figure we can see the base class 1 is the parent class of derived class 1 and derived class 1 is the parent class of derived class 3, which makes it multi-level inheritance. But if you look at it in this way, that the base class 1 is the parent class of derived class 1, derived class 2 and derived class 3, then it is hierarchical inheritance, as multiple classes are inherited from a common base class. So we can say it is a combination of more than one type of inheritance or a hybrid inheritance. So as we have understood about inheritance in C++, so now let's go to its practical aspect and do some examples on our code editor, that is VS Code. So this is our Visual Studio Code, and now we will do an example of inheritance. We'll start by doing the single inheritance example, in which we will make a parent class and a child class. And let's start. First of all, we'll create a file, and let's name this file as, let's name it inherit.cpp. So here we will do an example in which we will create two classes, a base class and a derived class, and we'll create functions in those classes, like we'll create one function in base class and one function in derived class, and using the object of derived class we will access the member of parent class or base class. So let's start. First of all, we'll include the header files, hash include iostream. Now the namespace standard using namespace std. Now we'll create a base class first, then afterwards we'll create the main function. Alright, so let's create the base class. Let's say the name of the base class or the parent class would be beverage, and inside this class let's make the scope public, and now let's create a function as we have said, drinks. So this is a function and we will print something inside this function. So let's say we are printing all drinks are available. All drinks are available. Now we'll write endl. Now we will use semicolon in the end of the class. So this is our base class and we have created a function drinks and we have printed a message, all drinks are available. Alright, now we will create another class which is derived class or child class. We will write class coffee is the name of the derived class, and use the colon operator, public access specifier, and the name of the base class, that is beverage. Alright, now we'll write public access specifier inside this class, and we will create a function in this class also. Like, let's say the name of the function would be mocha. It is a kind of a coffee, so mocha, and we will print that mocha tastes good, tastes the best, I would say. Okay, now let's use the colon operator in the end of the class. So here we have created the parent class or base class and this derived class or child class. So now we will create the main function where we'll do the calling. So now we will create the object of child class. So our child class is coffee, and now we will create the object, that is C, the name of the class and the object. Okay, now we will use the object with dot operator and call this function, that is drinks. And now using the same object we will call the mocha. The spelling is wrong. Yeah, now it is right. Mocha. So using the object of child class, here we are calling the drinks function which is of the parent class. So let's see if it works or not. Let's save it and now run it. As you can see, all drinks are available and mocha tastes the best. Both of these are getting printed. That means the object of child class is able to access the member of the parent class. So this is inheritance. When the child class acquires or inherits the behavior or characteristics from a parent class or access the members of the parent class. This is an example of single inheritance. So now let's do another example of multiple inheritance. So let's create a new file and name it as inherit2.cpp. Alright, now here we will do an example of multiple inheritance in which we will create two base classes and a derived class. As we know that in multiple inheritance there are more than one base classes to a single derived class. So let's start. First of all, we'll include the header file. Now we'll use the namespace standard, and now we will create a class, that is the base class, and we'll name it as party. So class party. Inside this base class we will first of all declare the public scope, and now we will declare a variable, let's say meals. So now we will create a function, and in this function we will take the input from the user about the number of meals to enter the number of meals. So let's start void food. This is the function name, and first of all we'll display the message saying that enter number of meals. Alright, now we will take the input and meals is the variable. Now we will use the semicolon at the end of this class. So in this function we are taking the input of the number of meals. Now in the other class, that is another base class, we will take the input of number of drinks from the users, and then in the derived class we figure out the total bill of the party. Alright, now we will create another base class, that is drinks, not drinks, drinks. Alright, now we'll write the public scope, and similarly we will create or declare another variable drink, and then now we will create a function. Let's say the name of the function is liquor. Alright, Now inside this function we will take the input from the user regarding the number of drinks. So we'll display the message enter the number of drinks. So the user will enter the total number of drinks used in the party or consumed in the party. Similarly goes for the meals. Now we will take the input and we'll write drink. Alright, now we have created this liquor function. Now we will use the semicolon at the end of the class. So here we have created both the base classes, that is class party and class drinks. Now we have to create the derived class. So this is an example of multiple inheritance. So we will create the derived class and use the colon operator. Now we will write the public specifier and the name of the base class. First base class would be party, separated with comma. The second base class would be drinks. Alright, so this is how we can do that. Now inside this class we will first of all create three variables. Let's say int total meals, int total drinks, and int total bill, because in the end we have to find out the total bill. Alright, now inside the public scope we will create a function name as total. Now inside this total function we will write the logic to calculate the total bill. So what we'll do is, first of all write the total meals equals meals into the price of a single meal. Let's say the price of a single meal is 90. So the total product would be stored in total meals. Alright, now we'll do same for total drinks. Total drinks, not frinks, equals drink into, let's say the price of a single drink is 60. Yes. Alright, now after that we have to compute or calculate the total bill. Total bill would be the addition of both of these, total meals plus total drinks. So we'll simply do the addition over here. Total drinks. So once it's calculated, we'll simply display a message saying that the total bill for the party is, and we'll write the variable that is total bill, where the total bill is actually getting stored. Alright, after this we will use the semicolon. So this is the derived class. Here we have calculated the total money spent in the party. So now we have to write the main function where it all started. Inside the main function, first of all we will create the object of child class. So we know that our child class or the derived class is bill. So bill is the derived class and b would be the object. So using this b, we will first of all call a function that is food function. So by calling this, we will take the input of number of meals. Now we will call another function named liquor. Alright, using this function, calling this function, we will take the number of drinks from the user. Now we will call this total function. So this will calculate the total money spent in the party, and after that let's say return 0. We are calling all of these functions using the object of derived class, and this is where multiple inheritance is going on. So let's see whether it works or not. We will save it and we'll try to run this. Enter number of meals, as we can see. Enter number of meals. Let's say the number of meals would be 20. It was a short party. Then enter number of drinks. 17 would be. So our total bill for the party is 3270, which is the correct answer. So this is how we can do multiple inheritance, and this is a fine example of multiple inheritance. Now let's do another example. So let's name this one as inherit3.cpp. Alright, so here we will do an example of multi-level inheritance, and we know that in multi-level inheritance a single derived class is inherited from another derived class, or in other words we can say a class extends a class which further extends another class. Then it is called a multi-level inheritance, as the name suggests. So we will do example of that. In this example, we will calculate the marks of a student scored by him in 3 subjects. We will calculate the total marks scored by him using multi-level inheritance. So let's do this. So first of all, we will include the header file #include iostream. Then we will write the namespace standard. Now we will create the class, base class chemistry. Alright, in this class, first of all, we will make the public scope and marks1. So here we will take the input of marks scored by that particular child in this chemistry subject. So we'll create the chemistry function, void chemistry. It is of same name as that of class. So let's say chemistry marks. Alright, now we will display the marks scored in chemistry. Enter the marks scored in chemistry. Spelling is wrong. Okay, now we'll take the input marks1. So the student will enter the marks. After that, let's put semicolon in the end. Now we'll create another class named physics, which is inherited from chemistry class. That is, chemistry class is its base class, chemistry. Alright, so in this class we will do the same, public int marks2. Now we'll write void physics marks. We'll do the same as we have done in the previous class. So now we will display a message saying that enter the marks scored in physics. Alright, now we will take the input cin marks2. Alright, so now we will put semicolon in the end of this class as well. So now we know that this physics class is inherited from this chemistry class. That is, the chemistry class is the base class of physics class. Now we'll do same for maths, like class maths, which is inherited from the physics class. We will write physics. Inside this class as well, we'll do the same. And as you can see, this physics class is the base class of maths, and the base class of physics class is chemistry. So this is a multi-level inheritance. So in this class we'll do the same, public scope, and now after public scope, int marks3 is the variable we have declared, and we will declare another variable in this one, like total, because we have to find out the total marks. Now function maths marks. Inside this one we will display the message that enter the marks scored in maths. Alright, now we'll take the input marks3 and we'll write the semicolon in the end. So here we have created all of these 3 classes, which is of multi-level inheritance. As you can see, we have taken the input from the user of its maths, physics and chemistry marks. Now we'll do the total. So we have to do the total inside this class only. So the name would be result function. So the total variable that we have declared is equal to marks1, marks2 plus marks3. So physics, chemistry and maths marks, we will add all of them and then we will display the total. Alright, now this is done. Now we have to go to the main function. Now first of all, we will create the object of child class maths. Once this object is created, now we can call the functions, as it can access the base classes. So chemistry marks first of all, then m dot physics marks, m dot maths marks, and then the total, that is result function, m dot result. Then we'll write return 0. So return 0. So here first of all, m dot chemistry marks will call this function in the chemistry class. So the user will enter the marks scored by him in chemistry. Then this will call physics marks, so the user will enter the marks scored by him in physics subject. Then similarly we will maths marks, they will enter the marks of maths. Then we will call the result function, we will do the total of all the marks scored by the student. We will do the total and then we will display that total. So pretty much it's done. Now we can save it, and now let's try to run this one. There are some errors. Alright, that's a silly one. By mistake we have done this. Alright, now let's save it and run it again. Hope it works now. Yeah, another error. Marks. Now let's try again. This is the right answer. 80 plus 80 plus 75 is equal to 235, and using the object of child class we have called the functions of all of these base classes. Like we have called this chemistry marks function and this physics marks function, which is of base class. And this was a fine example of multi-level inheritance, and this is how we can do multi-level inheritance. So these were some examples of C++ inheritance. You can try some more examples on it, and these were some decent examples. To understand it better, you can start with some basic level examples, then go to the intermediate level, and we will learn about C++ polymorphism. So let's go ahead and have a look at what we'll be covering today. So we'll start with what is polymorphism in C++. Then types of polymorphism in C++, that is compile time and runtime. We'll also study function overloading and operator overloading under compile time polymorphism. And under runtime polymorphism, we will learn about function overriding and virtual function in C++. But before we begin, make sure to subscribe to our channel and press the bell icon to never miss an update from SimpliLearn. So what is polymorphism in C++? Polymorphism is an important topic of C++ OOPS concept. The word polymorphism is derived from two words, that is poly, which means many, and morphs, which means forms. So basically it means many forms. Polymorphism in C++ can be defined as when the member function or the object behaves differently in different situations or circumstances. Then it can be called as polymorphism. For example, a mother has different relationships with different family members inside the house. For example, she is a parent to her child, she is a wife to her husband, she is a sister to her brother, and she is also a daughter to her parents. So we can say a mother as a single entity has different behavior among different members. And same goes for polymorphism, where functions behave differently in different situations. Now, let's understand the types of polymorphism. There are two types of polymorphism in C++, that is compile time polymorphism and runtime polymorphism. So let's start with compile time polymorphism. As the name suggests, this type of polymorphism occurs during the compile time, and it is achieved by overloading the function or overloading the operator, that is, by function overloading or operator overloading. So what is this function overloading? Function overloading is a feature in C++ where the functions having the same name but different in terms of parameters or type of parameters can be overloaded. For example, as we can see, two functions with same name func differ in the type of arguments. One data type is double, another data type is integer. So when we make a call to the function with arguments of type double, it will invoke the suitable function, and the same goes for the other one. In example 2, there is a difference in number of parameters among functions. So while calling the function, if we pass two arguments, it will invoke the first function, and if we will pass three arguments, then it will invoke the second function. Then next is operator overloading. Like functions, operators can also be overloaded. In operator overloading, we can redefine the functionality of the operator. It helps us in redefining the already existing operator. For example, instead of writing sum equals s1.add s2, we can easily write sum equals s1 plus s2. That is, we can redefine the plus operator and use it to add the numbers in the operator function. And we will discuss the syntax of operator overloading in the examples. Now, coming to runtime polymorphism. In this type of polymorphism, the functions are invoked during the execution of program, that is, during runtime. This runtime polymorphism can be achieved through function overriding. So let's understand this function overriding. In function overriding, the function of the base class gets a new definition in the derived class. In this, more than one function has the same name and same type of parameters. The only difference is in the definition of both the functions. That is, functions have different definitions in the parent class and the child class. As you can see in the example, void message function has a different definition in the parent class and in the child class. Both have the same name, but in parent class it is printing hello there, and in child class it is printing nice to meet you. By using the object of the base class or derived class, we can invoke the suitable function. So let's move on to our next topic, that is virtual function. Virtual function is also used to achieve runtime polymorphism. It is a function that is defined in the base class and then is redefined in the derived class. The function is defined using the word virtual in the base class, and the name of the function is same as that of the derived class, having different definitions as shown. It tells the compiler to perform the late binding on the function in derived class. The function call is resolved at runtime and in late binding, and the compiler determines the object type at runtime. With the help of virtual function, we can invoke the derived version of the function in the derived class. So as we have covered the theoretical aspect of C++ polymorphism, so let's go ahead and cover the practical aspect of this topic in our code editor, that is VS Code.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by SimpliLearn. Click on the link in the description to know more.
So here we will make a new file and let's name it as poly1.cpp. Alright, poly1.cpp. So let's save it. So here we will do an example of function overloading, which is used to achieve compile time polymorphism. And we know function overloading is a feature in C++ in which two functions have same name but differ in terms of parameters or number of parameters, or the type of parameters can be overloaded. So let's start. First of all, we'll write the header file #include iostream. Now using namespace standard. Alright, so now we will create a class king, and inside that class we'll do the overloading. So the class name is king, and inside the class, first of all, let's make public scope. Now we'll create a function. Return type is void and the name of the function would be pro. Inside this function, let's say we are passing two arguments, int a and b. Alright, now we'll print both of these arguments or variables inside this function. Alright, and we'll use endl in the end. Okay, after that we'll create another function, and the name of the function is same, that is pro, but in this case we'll make the arguments like int a, int b, int c, int d, and int e. So there are 5 arguments in this function, second function pro. As we know that the name of the function is same, and now inside this function we'll simply add all of these. So a plus b plus c plus d plus e. Alright, once we are done with this, we'll use semicolon in the end of the class. Alright, now we'll start with the main function. Inside the main function, we will create the object of king class, king and the object would be k. With the help of this object k, we will call these functions. As we know, the name of the functions are same. The only difference is in the number of arguments. So I'll call the pro function, which accepts only 2 arguments. So the first pro function will be invoked. So I'll pass 10 and 20. So these 2 arguments will be passed over here. Alright. Similarly, now we'll call the pro function again, but now we'll pass 5 arguments so that the second pro function would be invoked. So let's say I'm passing 12, 23, 20 and 62, 6. These are some random numbers. Alright, now return 0 in the end. Now let's try to run this. I think we are done with this. First of all, let's save it, and now let's try to run this. So this is our output, 10, 20. Let's multiply both of them. It will look good. Let's save it and run it again. As you can see, 200 and 123. So this is our output. 10 into 20 would become 200, and if we add all of these, we'll get 123. So this is our correct output. So this was the example of function overloading, and let's start with another example. So now let's create a new file and name this file as poly2.cpp. Alright, we have saved it. Now here we will do an example of operator overloading. As we know that in operator overloading we give definition to already existing operators, or we can say we can redefine the functionality of already existing operators. So let's start. First of all, we'll include the header files as we have done previously. Hash include iostream, then the namespace standard. So first of all, we'll start with the main function, and inside the main function we will write the name of the class that we will create and the object. Let's say the name of the object is O1, and we'll pass the arguments to the constructor. Let's say the argument is 6 and 8. Alright, then I think we can write return 0, and we'll do the rest afterwards. First of all, we will create the class. So as we know that the name of the class is overload, so let's create it, class overload. And inside this class, inside the private scope, we'll start with the variables. Let's say the first variable is n1, and let's declare another variable n2. Then we will create the public scope. Inside this we will create the parameterized constructor, so it is of same name as that of the class, that is overload. And now as the constructor is parameterized, so int num1 and num2 are the parameters. So when we'll create this object O1 and we'll pass these arguments, so it will go here. And alright, inside this, in the definition of this constructor, we will declare the variable res, and we will assign num to n1, we'll assign num2 to n2, and let's say we'll do the subtraction. Alright, n1 minus n2. Alright, now we will display the result, that is res. So res and then the variable res. After that we'll use sendl. Alright, so once we are done with this parameterized constructor, then we will create a operator function. So void is the return type, then we will write operator keyword. This is the syntax of operator function. Then after writing the keyword, we'll write the symbol. Let's say minus is the symbol. Then the arguments, if there are any arguments, then we can put those. Then inside the function, that is in the definition, we can perform whatever the functionality we want to perform. So let's say in this case we'll just make the numbers negative, so we'll do that. Alright, now we'll do the calling part of this. We'll simply use the symbol and the operator, and this is how we'll call the operator function. This is very simple, and after that we have to display the digits as well, as we have made them negative in this part. So we'll create a function display, and inside this function we will display those digits or numbers. So we'll write n1 Alright, after this we'll do same for n2, so we'll write n2, then there is ndl in the end. Alright, so here we are displaying this. So once we are done with this, the class is finished, so we can use the semicolon in the end. And we have to call this void function as well, so we will write o1.display. Alright, we are done. Let's see whether it works or not. Let's save it and check it. So as we can see, the result is -2, that is 6 minus 8 equals -2, that is correct, and n1 is -6 and n2 is -8 because we have made them negative inside this operator function. We forgot to add some space in n2 and n1, so that is why it is looking like this, but the answer is correct, and this is how we can do the operator overloading. In this part we have used the return type, then the operator keyword, then the symbol, and if there are any arguments then we can pass those arguments, and if there are not, we can put it like this. So this is our example of operator overloading. Let's do another example. So now we'll do an example of function overriding. So let's name this poly3.cpp. So in function overriding, the function of base class gets a new definition in the child class, and when we call the function of the child class using the object of child class, then the function of base class gets overridden. So now let's do the example of this function overriding. I think we have named it wrong. poly3.cpp. Alright, let's name it 4. poly4.cpp. Alright, now let's save it. Now include the header files. Using namespace standard. Now we'll start with the class parent. So this is the base class and we have named it parent. Inside the parent class we will create a function. For that we'll create the public scope. Inside the public scope we will create the function print, and we will display the message, this is the function of parent class or base class whatsoever. Alright, so this is class parent and semicolon in the end of the class. Now we'll create the child class, child derived from parent class. Name of the class is parent. Similarly, we'll do the public scope and create the function void print. So it is same function as that of the above class, and inside this function we will display this is the function of child class, derived class, let's say. Alright, once we are done with this, semicolon in the end and semicolon in the end of the class as well. Then we can create a main function, and inside the main function we will create the object of child class, child obj. So as we have created the object of child class or derived class, so with the help of this we will override the function of the base class. So we'll write obj dot print, which is the name of the function. So as we have created the object of child class, so it will call the derived class or child class function, and in the end let's say return 0. Now save it and try to run this. This is the function of derived class. So as we have expected, so it is calling the child class function. So this function of the parent class gets overridden as we have used the object of child class and call this function print, which is of same name. So this function which is in the child class gets to print derived class. So this is our output. So now let's do an example of virtual function in C++. Virtual functions are defined in the base class to ensure that the functions gets overridden, and when we use the base class pointer to hold the derived class object or the child class object, the base class pointer will always call the base version of the function and not the derived version. So to solve this problem we use the virtual keyword in C++. So now let's start with it. First of all we'll write hash include iostream. Now the namespace standard. Now we will create the base class, class base, and then we'll use the public scope. Inside the public scope we will create the virtual function. Use the virtual, the return type, then the name of the function, that is print. And we have created this virtual function inside the base class. Now we'll print. This is the function inside the base class as we have done previously in the previous question. This function, this is the function of base class. Yeah, it would be right. Alright, once we are done with this, we'll close the class by using semicolon. Now we'll create the derived class and we'll name it derived from the base class, whose name is base itself. Now here we will use the public scope and we'll create the function of derived class, print function, and we'll print this is the function of derived class. Alright. Now we'll use the semicolon to end the class. Now inside the int main function, first of all we will create the pointer of base class. Base dereference operator b. So we have created the pointer of base class. Now we will create the object of derived class, derived d. So now we will store the address of derived class object to the pointer of base class. So let's do that. B, which is a pointer of base class, address of operator, the object of derived class. So now we will call the print function using the pointer of base class, and it will print the derived class function because the pointer of base class which we are using to call the functions points to the derived class object. So now let's do the calling part. All we need to do is the pointer and the arrow operator and the name of the function, that is print. After that we can write return 0. Now everything is done. Let's save this and run it. As we can see, this is the function of derived class. Here we can see. So the derived class function is getting called, which we wanted. So this is an example of virtual function in C++. We have used this virtual keyword over here, and using the base class pointer we have called this function, and these were some examples of different topics in polymorphism in C++. You can try some more examples on these topics. It will help you in understanding this topic in a better way. In today's session we will learn about C++ operator overloading. So without further ado, let's get started. So we will be covering today what is operator overloading, then we will discuss non-overloadable operators. After that we will learn types of operator overloading in C++, that is unary operator overloading and binary operator overloading. So first is, what is operator overloading? Operator overloading is a special case of polymorphism in which the operator is overloaded to provide special meaning to the user-defined data type. Basically, it adds some features or redefines the functionality of already existing operators. For example, let us suppose we have three objects of same class, namely A, B, C, and C equals A minus B. Now here we can redefine how minus operator works, and we can write C equals A minus B instead of writing C equals to A dot subtract B. And this is the general syntax of operator overloading. First is the return type of the function. After that, operator is the keyword, then symbol is the operator we want to overload, then the arguments are those which are passed to the function. Now let's move on to the non-overloadable operators. There are some operators in C++ that cannot be overloaded because it is not syntactically possible to overload them. First is the dot operator, then next is scope resolution operator, and third is pointer to member operator, and at last we have ternary operator. Coming to the next topic, that is types of operator overloading in C++. So there are two types of operator overloading, that is unary operator overloading and binary operator overloading. First is unary operator overloading. It is defined as an operator which contains only one operand or works on only one operand. Increment operator and decrement operator are examples of it. There are two ways to do operator overloading, that is from the class function and the friend function. Its syntax using class function is the return type, operator keyword, then the symbol and the brackets. But if we are doing postfix in the function, then we have to write the data type inside the brackets. Syntax using friend function is friend keyword, return type, then operator keyword, after that symbol, and in case of friend function we have to pass an argument. Next is binary operator overloading. An operator which contains two operands or works with two operands is called binary operator overloading. Addition, subtraction, multiplication are examples of binary operator overloading. Syntax using class function is return type, then operator keyword, then the symbol, and then we have to pass an argument inside the brackets. And syntax using friend function is friend keyword, then the return type, after that operator keyword, and then the symbol, and in case of friend function we can pass 2 arguments. Now we will do one example of unary operator overloading in which we will increment the value of the variable with the help of operator overloading. So now let's move on to our code editor, that is VS Code. So here first of all we'll make a new file and name that file as operator.cpp. Now first of all we'll write the header files #include iostream. Now we'll write the namespace standard. Now we'll start with int main, and inside int main first of all we'll write the name of the class, that is increase, and its object inc. Now we will call the void operator increment function. So we will write ++inc. Here when we write ++inc, then function void operator ++ will be called, which we will make later. So as of now, first of all we write inc.display in order to display the output. We are calling the display function over here. Now after that we'll write return 0. Now we'll make the class. So we'll write class increase, which is the name of the class. Now we'll use the access specifier private, and we'll write the variable int value. Now we'll write another access specifier public, and now we will make the constructor because we have created the object inc. So that is why a constructor is called, and we are making it increase. And inside the constructor we have given the value 10 to the variable. Now ++inc is calling the void operator ++ function. So we'll write that function void operator increment, which is the symbol. Now value equals value +5 because we are incrementing the variable with 5. So we'll write value equals value +5. Now after that we have to display the value variable. So we will write void display, because we have already called over here inc.display. So now we will write inside cout, we'll write the message value is now the variable value and endl. After the class we have to use the semicolon. Now let's try to run this. Here is our output. Value is 15. Previously the value was 10, then on increment its value gets 15, which is the right output. So here first of all we have created an object and constructor is called, and inside the constructor we have initialized value with 10. Then with the help of object inc, that is when we are using ++inc, then we are calling the void operator function, which is increasing the value of the variable by 5, and then we are displaying it with the help of display function. And one more thing guys, in case of postfix, that is in case of I and C++, we have to write the data type inside the void operator function, that is over here. Now let's do another example for binary operator overloading. So let's name this operator 2.cpp. Now here we will do one example of binary operator overloading in which we will add two complex numbers. So let's start. First of all, let's make the header files. Hash include iostream. Now using namespace standard, now we'll write int main. Okay, now first of all we will write the name of the class, that is complex. So we'll write complex, and then the objects like com1, com2, res. We have created 3 objects. Now we will write a message because we have to take the input from the user. So first of all we'll write a message. Enter first complex number, because we have to add 2 complex numbers. So first of all we'll take the input of the first one, that is /n. Okay, now we have to write com1 dot input. Input is the name of the function which we will be creating afterwards. Then cout enter second complex number. That is, now we'll write /n. Okay, now after this we have to write the semicolon and we'll write com2 dot input. These input function will take the input of complex numbers from the user. We will declare them later, we will make them later. Okay, now here we will do an operation with the help of plus operator function. So we will write res equals com1 plus com2. This function call from com1 will go to the complex of operator plus function, and com2 will be passed to the argument obj, and the result will be stored in variable res. Okay, now we will call another function output in order to display the output. Res.output. After that we'll write return 0. Now we will make the class complex. We'll write class complex. We'll write the access specifier private and the variables int real and int imag, that is imaginary, because we know in complex number there is a real part and imaginary part. Okay, now we'll write public access specifier, and now we will write the function input. In order to take the input from the user, void input Now first of all we have to display a message. We will write enter real and imaginary parts respectively. Okay, now we will write C in because we have to take the input and the variable name real and imaginary. Now we will write the overloading function. We will write the return type, that is the complex, then operator keyword, then symbol, then argument, complex obj. Okay, now we will write complex temp. So here we have created the data type temp of complex class. We'll make it a capital C. Okay, now we will write temp.real equals to real plus obj.real. So we'll write temp.real equals to real plus obj.real. The plus operator over here will add the real part of the number to the real part of another number. And similarly we'll do it for the imaginary part. We'll write temp.imaginary equals imaginary plus obj.imaginary. And then the value of the variable temp is returned. So we'll write return temp. The value was stored in temp, so that is why we have returned temp. Now we will make the output function. We'll write void output. We'll write output is variable real, then we'll write plus, then imaginary, and then I, because this is the syntax for complex number. Okay, now we have to put the semicolon over here. As the value of temp is returned, now the result is stored in variable res, and then we will print the output using the output function. This is the output function, and the value is stored in res, and then we are printing the output using the output function. Com1 over here is getting passed to the complex of operator plus function, and com2 is getting passed to the argument obj, and the result is getting stored in res. Now let's try to run this code. The first complex number, let's say 2 plus 2 iota, so we will write 2 and 2. And then enter second complex number, that is enter real and imaginary parts respectively. Now we have to write the real and imaginary parts of the second complex number. So we'll write 4 plus 6 iota. So the output is 6 plus 8 iota. 2 plus 4 equals 6 and 2 plus 6 equals to 8. So this is our correct output. We are basically adding two complex numbers with the help of binary operator overloading. So this is how it is done. So these were some important examples of operator overloading. You can try some more examples on it in order to practice them well. Hey everyone, welcome back to another video by SimpliLearn. In this session, we will learn about encapsulation in C++. So let's go ahead and have a look at what we'll be covering today. So we'll start by understanding what is encapsulation in C++. Why do we need encapsulation in C++? Then we will learn about access modifiers. After that, we will understand the benefits of encapsulation and also the difference between encapsulation and abstraction. So let's start with encapsulation in C++. Encapsulation is a very important concept of object-oriented programming. It can be defined as wrapping up of data and functions together into a single unit. Just like a capsule, the data members and functions are wrapped together. Wrapping them into a single unit helps in keeping them secure from the outside access. For example, inside a class, the variables and functions are declared and then bind together with the help of class, which also implements encapsulation. Next is, why do we need encapsulation? Hiding the details or attributes is also an important thing that one should focus on. Encapsulation helps with that part. It keeps the details of the object hidden or safe from the users by securing them from the outside access. There are many implementation details that the users are not supposed to see. So these details, like the details of the object, are kept secure from the direct access from outside the class with the help of encapsulation. The data hiding is done with the help of access modifiers. So let's understand these access modifiers. The access modifiers helps in data hiding part. The access modifiers provides or grant the access to the members of the class, or it prevents them from the direct access to the class members from outside the class. So there are generally three types of access modifiers, that is public, private and protected. So let's understand them. In public access modifier, other classes and function can access the data members and member functions of the public class. For example, park is a public property. Anybody can go to the park or access the park because it's a public. Nobody has to take the allowance of anybody to go to the park. Now coming to the private. In private access modifiers, only the member functions inside the class have the access to the class members. Functions outside the class cannot access them. For example, a house is a private property. Any member outside the family cannot access the house without permission. Only members inside the family can access it because it's a private property. Now let's understand protected. In protected access modifier, similar to private scope, it cannot be accessed from the outside class, but it can be accessed from the derived class. The derived class is also called the child class. Also, the protected member of a class can be accessed from the friend function. So as we have understood about these access modifiers, now let's understand the benefits of encapsulation. Encapsulation helps in reducing the complexity of code by hiding the irrelevant data or information, and by doing so, it reduces the complexity. Second is, encapsulation helps in hiding and protecting the data by wrapping the data and functions together, which are generally complex, and by doing so, provides a simpler view to the user. With the help of encapsulation, the variables of the class can be hidden from other classes. Third is, encapsulated classes can easily be altered using the access modifiers. That is, we don't need to change the entire program. All we need to do is to change the access scope of the variables that can be private, protected or public. So these were some benefits of encapsulation. Now let's go ahead and understand the difference between encapsulation and abstraction. Both of these concepts are similar in some ways, but now we will discuss their differences. So let's start with encapsulation. Encapsulation helps in combining the data and functions together in a single unit, whereas in abstraction, the unwanted information is kept hidden. Encapsulation helps in hiding the data and helps in providing an easier view. Abstraction helps in hiding the implementation details. Encapsulation can be implemented using an access modifiers, whereas abstraction can be implemented using abstract class and interfaces. In encapsulation, problems are solved at implementation level, and in abstraction, problems are solved at design level. So these were some differences between encapsulation and abstraction. Let's go ahead and do some practical examples on this topic.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by SimpliLearn. Click on the link in the description to know more.
So this is our code editor, that is Visual Studio Code. And now let's create a new file and let's name it encapsulation.cpp. So first of all, we know in encapsulation we can make variables inaccessible by making their scope as private. So in this example we will do that. We'll make the salary of an employee as private, and then using the setter and getter methods we will set the value of salary and return it as well. The setter getter methods are generally used in these kind of situations where the variable we want to access is private. So now let's start. First of all, we will create the main function, but before that let's add the header files. Now using namespace standard. Now we'll start with the main function, and inside the main function first of all we'll create an object by declaring the class name. Let's say the class name is company and the object name is obj. Now using this object we will call the set function, or we can say the setter function. We will name it as set salary, let's say, and we will pass two values, 30,000 and 6,000. One would be the full-time salary and one would be the overtime. Alright, now after that we can display those, and we can write total salary and after that we can call the get function to return the salary, as the getter function is used to return the output and set function is used to set the values. So we'll write obj.get salary. So the salary we will display over here, and after that we can write the return 0. Now the main function is done. Now let's start with company, class company, and inside this class, first of all, inside the private scope, this is the private scope and this is the variable salary. Now this variable salary is private, so no member outside the class can access it, but using the setter and getter methods we will access this variable and we will set the salary and then we will return it. Alright, now public scope, inside the public scope we will write the setter methods, void set salary and int full time, int overtime. So these are two variables. This 30,000 that we are passing is a full-time salary and this 6,000 is an overtime salary. So we need to add both of these salaries in this part. So we'll write salary equals full-time plus overtime. So this would be the total salary, and let's just do this. Alright, so this set salary function is done. This is the setter function. Now we have to return using the getter function, so we'll write the data type int get salary. Now inside this function we will simply return the variable salary, as we can see, and once the class will use this semicolon. Alright, pretty much everything is done, and now we can save it and let's try. As you can see, total salary is 36,000 as 30,000 plus 6,000, so it is working fine. So this is how we can access these private variables using these setter and getter methods. Now let's do another example. This example of encapsulation will also be pretty much the same. We'll do the setter getter methods in this one as well, but in this example we'll find the area of circle. Alright, let's start then. First of all, we'll include the header files, that is hash include iostream, and the namespace standard. We also forgot to save this. Let's name this one as, first of all, the location is work. Now let's name it as encapsulation 2.cpp. Alright, now the header files are added. Now we'll start with the main function first of all. Now inside this main function we'll create an object. First of all, we'll write the name of the class, that is ball. Now the name of the object is obj. Now using this obj object we will call the setter function, that is the set area function, and we will pass the radius. Alright, obj dot set area, this is the setter function. Now we will pass the radius. Now we can display the area by calling that getter function, but before that we will display a message. We'll write area of ball is alright. Now we will call that getter function get area. Alright, the main function is done. Now we need to create the class. Class ball. Inside this class, private scope, inside the private scope we'll create that variable area, and let's make its data type as float, because we know that there are chances that the answer could be in decimal form, because we have to use pi in that, because the area of circle is pi r square, so 3.14 is the value, so that is why we are using float as the data type. Alright, now in the public scope we'll set the radius inside this function, set area and int radius. This is the radius, that is 6 that we are passing. This is the parameter, and inside this function area equals, we know that pi r square is the formula, so we'll write 3.14, that is the value of pi, into radius again into radius r square. Alright, so this is the area of circle or ball, we can say. After that, float is the data type. Now we have to return the area using the getter function, float getter, its name is get area, and we'll simply return the area variable. Alright, after that we can use semicolon in the end, and pretty much everything is done. So let's save it and let's check it if it is running fine or not. As you can see, area of ball is 113.04. So if we multiply 3.14, that is the value of pi, with 36, that is 6 into 6, it will give you 113.04. So this is the right answer, and this is how we can find the area of ball or something like that. And as we can see here, the area is private, and using these set area and get area methods, that is the setter and getter methods, we are accessing this private variable, that is area. So these were two examples of encapsulation. You can try these examples as well. Hello everyone, welcome back to another video by SimpliLearn. In this session, we will discuss an interesting topic, that is exception handling in C++. So let's go ahead and have a look at what we will be covering today. So we will start with what are exceptions, then why do we need exception handling in C++, and what exception handling is. Then we will understand exception handling keywords, that is try, catch and throw, and we will understand each keyword in detail. So first, we will start with what are exceptions. Exceptions are the unexpected events or the situations that arise during the smooth execution of the program. So there are times during the runtime when some errors or situations arises which create issues in the program. These issues are called exceptions. For example, let us suppose we want to divide two numbers, one is 7 and other one is 0. Now if we divide 7 with 0, it will show an error because we cannot divide any number by 0 because it is undefined. So exception handling provides a way to take care of problems like these. So now let's learn about exception handling, but before that we must understand why we need exception handling. So why do we need exception handling in C++? One of its reasons includes handling the exceptions that arise during the execution of the program. Along with that, exception handling provides a mechanism through which we can handle the error generating part separately from the rest of the code. Exception handling provides information to the user about the problem so that he or she can detect the mistake and correct it. Now, let's go ahead and understand what exception handling is. As we have discussed, exception handling helps in dealing or handling the exceptions that disrupts the flow of execution of a program. So how does it deal with the exception? So when an exception is encountered, it transfers the control from one part of the program to the other, known as handlers, and makes the code more readable and maintainable, and takes care of the exception by providing certain code. These exceptions are handled with the help of exception handling keywords. Now let's understand these exception handling keywords. So there are three exception handling keywords named try, catch and throw. As we can see in the example, first there is try block, then followed by three catch blocks, and each catch block contains the name of the exception. The try block can have more than one catch block. Inside the try block, those statements are enclosed which may cause the exception. Or we can say, in this block, that particular code is kept which will throw the exception. Each try block is followed by one or more than one catch block. The try block throws an exception which is caught by the catch block. Taking care or handling the exception is the actual job of catch block. This block catches the exception thrown from the try block. Inside the catch block, a message or some code is written to handle the exception. It can be a message for the user or a default code for a particular condition. Both the try block and catch block work together, and every try block has at least one catch block for it. Now next is throw keyword. Whenever an exception is encountered, it helps in throwing the exception. It is used to throw an exception and its value to the consecutive exception handler. So as we have discussed this topic theoretically, now let's go ahead and do its practical implementation in our code editor, that is VS Code. So this is our code editor. Here we will do an example in which we will make sure a person who is less than 24 years of age is not allowed to drink in the club. So we will create an exception in that part, and with the help of try, catch and throw blocks, we will handle those exceptions. Alright, so first of all, we'll create a new file and let's name it as exception1.cpp. Alright, now we'll start with the header files, that is hash include iostream. Now the namespace standard. Now we'll start with the main function. And inside the main function, first of all we will declare a variable named age. So we'll write int age equals to, let's assign it as 20. So this person is 20 years of age, and now we will create the try block. So inside this try block, we will write an if condition, that is if the age of the person is greater than equal to 24, then only he is allowed to drink. So inside this we will print a message saying that you have the access to drink the alcohol. Alright, so after this, inside the else block, all we need to do is to throw and the exception, that is if the age of the person is not greater than 24, that is age is less than 24. So in that condition or in that situation, we will throw the exception, that is we will throw age to the catch block, and for that we have to create the catch block. So the catch block will catch the exception, that is age, as you can see. Now inside this catch block, first of all we will write a message. We'll write you don't have the access to drink alcohol. You don't have because your age is less than 24. Alright, so after this message, we will print the age of the person. So we'll write your age is so and so, and then the variable age. Now after that we'll write return 0. So in this example, as we can see, the person age is 20 as we have assigned, and inside the try block we have set a condition that if the age of person is greater than 24, greater than equal to 24, then he or she have the access to drink the alcohol, and if not, if his or her age is not greater than 24, then we'll throw the exception and the catch block will catch the exception and will print this message that you don't have the access to drink alcohol because your age is less than 24, and then his age will be printed. So now let's try to run this. I hope it works. As you can see, you don't have the access to drink alcohol because your age is less than 24 and your age is 20. And now let's try to, if we assign, let's say 25. The program is working fine, but we want to check the other condition as well. Okay, so it is happening because we forgot to save this 25. As we have now saved it, now let's try to run this. As you can see, you have the access to drink alcohol because now our age is 25. So this is how exception handling works. This try block, inside this try block we kept those code or statements which will throw the exception, and then it is thrown with the help of this throw keyword, and then the catch block solves or prints a message with respect to that exception. So now let's do another example. So let's create a new file and name it, let's say, exception2.cpp. Alright, so here we'll do an example in which we will try to divide a number by 0. And as we know that we cannot divide a number by 0, so it will throw an exception. So let's do this example. So first of all, our hash include iostream, the header file. Then the namespace standard. Now inside the main function, we will create 3 variables. Main. So inside the main function, we will create 3 variables. One is for the numerator, then denominator, and then in which we will store the output, that is the output variable. So let's name numerator as num and denominator as denum because it is sounding familiar. Then we will store the output in the output variable. Alright, so we have created 3 variables, num, denum and output. Now first of all, here we will display a message to enter the numerator and denominators. So we'll write, please enter the numbers to do the division. Alright, after that endl. Now we'll take the input C in num and C in denum. So the numerator and denominator, we have taken the input from the user. Now after that we'll make the try block. So inside this try block we will create an if condition and we'll write if denum, that is the denominator, is equal to 0. If it is equal to 0, then we will throw the exception, and the exception would be denum because denominator cannot be 0. And if the denum is not 0, then in else condition we will simply divide. Output equals to num divided by denum. Alright, so now after this we have to create the catch block also because we have thrown the exception. Now we want the catch to catch the exception. So we can write D for denum here. Now we'll print a message saying that you cannot enter 0 in the denominator. So we'll write you cannot enter 0 in denominator while doing the division operation. Alright, now after that we'll use endl. So this is our catch block. After this catch block we will again write a message that the output of the division is, that is, if the denominator is not 0, then we have to print that result. So for that we will do this. The output after the division is, and here we will write the variable output. So this will print the result of this one where the denominator is not 0. So after that we can write return 0. So there is one extra bracket, as we can see, of try block. Alright, now it's done. We can save this one and let's try to run this. But before running this one, let's go through this code. That first of all we have declared these three variables. Then we ask the user to enter the numerator and denominator. So then we have used this try block, and inside the try block we have set the condition that if denominator is 0, then we will throw the exception, and if it is not, then we'll simply divide both of the numerator and denominator. So the denominator which is thrown is called by this catch block, this, and it will display a message that you cannot enter 0 in the denominator while doing the division operation because it is undefined. And if the denominator is not 0, then it will simply print the message and the output. So now let's try to run this. So as we can see, please enter the numbers to do the division. So let's say the first number is 8 and second number is 0, that is denominator is 0. Then you cannot enter 0 in the denominator while doing the division operation. The output after division is 0. So it will show this output only, and our output is correct. Now let's try to run this and do the simple division operation in which the denominator is not 0. So let's say now again we'll write 8 and the denominator would be 2. Then as we can see, the output after the division is 4. So our code is correct and our output is also correct. So this is how we can do the exception handling and handle the exceptions using this try, catch and throw blocks. Welcome to this tutorial on C++ vectors. So let's jump in and see what's in it for us. So we will be covering today why we use vectors in C++, what is a vector in C++ and its syntax. Then we will go through the member functions of vectors like modifiers, iterators, capacity, and we will understand each of their functions also. So first is why we use vectors in C++. Vectors are used when we are not sure about the size of data. Like in case of arrays, we have to guess the size of the data first because it is not possible to resize it later. But in case of vectors, we don't have to set the size of vector and it is resizable. That is why it is more preferable for dynamic elements. And it also has some inbuilt functions like pushback, size, empty, etc., which helps in dealing with data values. Now let's understand what is a vector. Vectors are array-like containers that is used to store data, and the data is stored in contiguous storage locations. But unlike arrays, its size can be changed automatically depending on the number of elements, and it is not necessary to mention the size of vector while declaring it. Now let's have a look at the syntax here. Inside the angle brackets, this is the data type of the vector. It can be string, int, float, etc., and v2, v1, v3 are the names of the vectors respectively. Now let's understand the member functions of vectors. A vector container has three types of member functions, that is modifiers, iterators and capacity. So let's understand these functions in detail. First is modifiers. These are those functions that are used to modify data elements. For example, first is pushback function. This function is used to add a new element to the end of the vector. Next is popback. This function deletes the last element of the vector. Then there is insert function. It is used to insert a new element at a specified position. In this function there are two parameters. First parameter specifies the position and second specifies the value. After that, erase function. Erase function is used to remove the elements at a certain position or to remove a range of elements. Either you can write the position of the element you want to remove inside the bracket, or you can write starting position and ending position of the range of elements inside it. Next is swap function. This function is used to swap the contents or elements between two vectors. And if there are two vectors named v1 and v2 that we want to swap, then its syntax would be v1.swap v2. Then there is assign function. This function is used to assign values to the vector. In this function there are two parameters. First one specifies number of values to be assigned and second represents the value that is to be assigned. Last is clear function. This function is used to remove all the elements from the vector. Now moving on to iterator functions. These are those functions that helps in iterating across the elements. First is begin function. It basically returns the iterator pointing to the beginning of the vector. The next is end function. This function returns the iterator pointing to the end of the vector. Now coming to capacity functions. These functions that lie under capacity are associated with size. So first is size function. This function returns the number of elements in the vector. Next is max size function. This function returns the maximum size that a vector can hold. Then there is resize function. This function changes the size of the container, and inside the brackets a number n is mentioned. If n is less than the size of container, then content is reduced by removing extra elements. But if n is greater than the size of the container, then extra elements are added at the end so that it reaches the size of n. After that, capacity function. This function returns the size that is currently allocated to the vector container. At last, there is empty function, which checks whether the vector is empty or not. If it returns true, then it is empty, and if false, then it is not empty. Now, to understand these vector functions in a better way, let's do some examples of these vector functions in our code editor, that is VS Code. So first of all, let's make a new file and name this file vector.cpp. Now first of all we will write the header file, that is #include iostream. Now we will write the header file #include vector. This is the header file for vector because we are doing some examples on vectors, so that is why we have to use it. Now we'll write the namespace standard using namespace std. Now we'll start with int main. Now first of all we'll define the vector, so we'll write vector, and inside the angle bracket we will write int, which is the data type. Now the name of the vector, we'll write n. Now first of all we'll see the functionality of assign function. As we know that assign basically puts the value at positions, so we will write n dot assign. Now first of all we'll write the number of values, like 9 is the number of values. After that, in the second parameter we'll write the value. Here it means that we are putting 1 to 9 positions in the vector. That is, we are assigning 1 to 9 positions. Now in order to print this, first of all we'll display a message saying the contents are. Now, in order to print these contents, basically we have to write a for loop. We'll write int a equals 0. We'll initialize it from 0. Then a less than n dot size. This is the size function. It basically returns the number of elements. Now a++ will increment. We have to now print this. We have to write like an array in order to print all the elements. We'll write n and inside the bracket a. Now we'll leave some space. We'll write and l. We wrote and l over here in order to insert a new line. Now after that we'll see the functionality of another function, that is pushback. And we know that pushback functions adds an element at the end of the vector. So we will write n dot pushback and then the element which we want to add, like let's say 2. Now we have to display this last element also. So in order to display this, we will store the size of vector in some variable and then we will print the last element. So we will write int no, this is the variable name. Then we will write n dot size. Here we are storing the size of the vector in some variable no. Now we'll display last element. We'll display the message saying last element. And then we will print the last element, and as we know, in order to print the last element we have to print the n-1th element. So we will write n bracket no minus 1. Here we are writing n bracket no minus 1. This will print the last element. After that we'll write and l. Now after that we will see another function, that is popback. It basically removes the last element. So we'll write n pop underscore back. So this function will remove the last element that we have added, that is 2. So we need to print this also. So we'll write, first of all we'll display a message. Now the contents are Now we again write the for loop as we have done previously. We'll write int a equals 0, a less than n dot size, a++. Now we'll again print in the form of array. And inside the bracket we will write a. Then in order to give some space we'll write this. After this we'll write and l to add one new line. So firstly we displayed the contents, then we added one element at the end and then displayed that element. After that we have removed that element with the help of popback function. As you have noticed that we are just doing the functions of modifiers yet. So in this example we will cover some functions of modifiers only. Then in the next examples we will do for iterator functions and then for the capacity function. So now let's do the functionality of insert function. As we know that insert function is used to add an element at a specified position. So we will write n dot insert n dot begin. It will point to the first element, then 7. As we know that the first parameter specifies position and the second specifies the value. So n dot begin will point to the first position and 7 is the value. So now we will print it also. We'll write first element is, then we will write display the first element, then we'll write endl. Now we will use the function clear to remove all the elements. We'll write n dot clear clear, and then in order to check we will write n dot size. So first of all we'll write now the size is, and in order to check whether all the elements are removed or not, we'll write n dot size. It will display the size. The program is pretty long, but let's just hope it runs. Here it is. Now the contents are last element. Let's have a look whether it is right or not. 1 is displaying 9 times, then last element we have added 2, then we have removed that element. It is also correct. Then the first element we have added using insert, 7 is there, and after using clear function now the size is 0. So this is the correct output. Now after doing this function, let's try another example. Now here we will do the example of iterator functions, in which first of all we will add some elements inside the vector and then we will print them using iterators. So let's start. First of all name this vectors2.cpp. Now first of all we'll write the header file #include iostream, then the header file for vectors #include vector, then we'll use namespace standard. Now we'll start with int main. So here we will write vector, and inside the angle brackets we'll write the data type, that is int, and then the name of the vector, that is num. Now we will write the for loop, and with the help of for loop we'll add the elements inside the vector one by one. So we will write for int I equals 0, I less than, let's say 5, I plus plus. Let's make it 1 over here. Okay, now after that we'll push these elements one by one inside the vector. So we will write the function pushback. We'll write num dot push back, and here I will write I. Okay, now because we want to add the elements from 1 to 5, so that is why we have to use less than equal to, because we want to include 5 also. Okay, now we have to print these elements, right? So we'll write, first of all we'll display that output from the beginning to the end. Okay, now we will write for loop, and with the help of iterators we will print the elements of vector. So we'll write auto, this is the iterator and A is the iterator name. Then we'll write num.begin. As we know that begin function points to the first element of the vector, so that is why we have written num.begin. Now we will write A less than, sorry, not equal to num.end, then A++. Now after that we have written A not equal to num.end, and we know that end function returns the iterator to the end of the vector. And after that we have used increment operator, so this loop will run from beginning till it reaches to the end. And inside for loop we will write the dereference operator with A, so that each element which is getting pointed by A will display one by one with the help of loop. So let's write, we'll write cout dereference operator A, and then we'll give some space. Now let's try to run this. This is the output from the beginning to end, 1 2 3 4 5. This is our right output. This is the message which we want to display, and this is the output 1 2 3 4 5 which we want to display, which we have added in the vector and then we have displayed. So now let's do another example which includes the capacity function. So we'll make another file, vector3.cpp. So in this example we will add some elements in the vector and then we will apply some functions on it. So let's start. First of all we'll include the header file, #include iostream. Then the header file for vectors, #include vector. Then we'll write the namespace standard using namespace std. Okay, now we will write int main. So first of all we'll write vector and then the data type and then the name of the vector, let's say v. Now one by one we'll put some elements inside the vector. So we'll write for loop. We'll start with int x equals 0, x less than equal to 10, x plus plus, because we want to add these elements. So we will write v dot push back and then we will write x inside the brackets, semicolon. Now here one by one all the elements from 0 to 10 will be added. Let's make it 1 to 10. Okay, now we will apply some functions on this vector. So let's first of all try out the size function. So first of all we'll write vector size is, and then we will write the function v dot size, and then we'll write endl. So this function will tell us the size of the vector because we have already added the elements from 1 to 10, so it will display 10. After that we will use the try out the capacity function. We'll write capacity of vector is, and then we will write v dot capacity. After that here also we'll write endl. Now we will use the maximum size or the max size, so we'll write maximum size of vector is. So in order to calculate the maximum size, we write v dot max underscore size handle. As we know that v dot size will give us the size of the vector, and capacity function, this function returns the size that is currently allocated to the vector container, and max size, this function returns the maximum size of the vector. So all of these functions result will be displayed because we have wrote them inside cout. Now let's try another function, that is resize. Now in order to resize the vector, we'll write v dot resize, and then we'll write the number that we want to resize it with, like let's write 5. Now in order to check this also, we will display, so we'll write vector size after resizing. Resizing is, I forgot to put the commas. Okay, now we'll write v dot size because now we want to find the size after resizing. So we have written v dot size. Now after that we will write endl. Okay, now we'll try the empty function. We'll put empty function inside if. Now inside if we'll write v dot empty equals false. It means if the vector is not empty, because we have written v dot empty equal to false, not true. We have written v dot empty equal to false. That means if it is not empty, then we'll display vector is not empty, and in else condition we will write vector is empty. So here we will write cout again I forgot to put over here. Okay, vector is not empty. And in the else condition we'll write vector is empty. So in this question, first of all, we have added some elements inside a vector. Then we have used v.size function, then v.capacity function, then max size function. After that, we have resized the vector and then check it for the size of it. After that, we use v.empty function. So now let's try to run this code. Okay, I think we have done something wrong. We haven't put the brackets over here. Okay, now let's try again. Here it is. Vector size is 10 because we have put 1 to 10. Then capacity of vector is 16. Okay, then max size of vector is this. Then vector size after resizing, because we have wrote the number 5 as we can see. So that is why vector size after resizing is 5. And vector is not empty as we know, because inside the vector there are 5 elements, so it is not empty, which is true. So these were some examples of vectors in C++. You can try some more examples on it, you can practice some more examples. And in today's session, we will learn about C++ STL. In this session, we will learn about what is STL. Then we will understand the components of STL like containers, iterators, algorithms, and function objects. So without further delay, let's get started. STL stands for Standard Template Library. It is a set of template classes that provide us data structures and algorithms or containers. It allows the programmer to use predefined functions, which helps them to write the code quickly and in an efficient way. For example, you are solving a problem that needs sorting. Now, instead of writing the code to sort, you can make use of STL. Now, STL mainly consists of 4 components, that is containers, iterators, algorithms, and function objects. So first is containers. These are collection of objects that store data of similar type. In STL, we have different types of containers. Some of them are array, vector, set, map, and these containers are generic in nature. So further, these containers are of 3 types, that is sequence container, associative container, and container adapters. Sequence containers, these are those containers that can be accessed sequentially. For example, vector, deque, list are some of the containers that store data in a linear form. Next is associative container. These are those containers that implement sorted data structures. In this, elements are retrieved via keys, and each associative container maintain its keys in sorted order. Example, set, multiset, map, and multimap. After that, container adapters. These containers are like sequential containers, but they are implemented by modifying their interface to provide the desired behavior. For example, stack queue and priority queue are some examples of container adapters. Now coming to iterators. In STL, iterator plays an important role as it links algorithms and containers. Iterators are those entities that helps in traversing through containers. They are used to point at the memory address of the STL containers. Iterators also helps in traversal from one element to the next element in the range using operators like increment operator. Iterator contains 2 functions, that is begin function and end function. The begin function returns the iterator to the first element, and the end function returns the iterator to the last element. Now coming to algorithms. Algorithms in STL can be defined as procedures that are applied to the containers and provide some operations on the content of the container. And because STL algorithms are built in, so that is why they save considerable amount of time. In algorithms, we just have to make a function call and we don't have to write the lines of code to implement it. Now let's have a look at types of algorithms. First is modifying algorithm, non-modifying algorithm, sorting algorithm, searching algorithm, and numeric algorithm. Modifying algorithms are those algorithms that make changes to the sequences. Swap and reverse functions are some examples of it. Then non-modifying algorithm. Non-modifying algorithm are basically read-only functions they do not modify the data on which they work on. Some examples are count, equal, and search functions. Then sorting algorithms. This algorithm is used to sort the container elements. Its example is sort function. Next is searching algorithm. As the name suggests, this algorithm searches for the element. Binary search algorithm is mostly used search algorithm. Last is numeric algorithm. This algorithm works on numeric values, or we can say it solves some numeric problems. Examples are accumulate function and partial sum functions. Now coming to function objects. Function objects are also known as functors. A function object is an object of template class that implements call operator. This call operator allows the object to be used with same syntax as regular function call. For example, suppose you have declared an object obj of a class in which operator is defined. Then you can use the object obj just like a normal function. Function objects also helps in generating the data, and it also helps in testing purposes. Now, in order to do some examples, let's move to our code editor, that is VS Code. So here we will do an example of vector container. So let's make a new file. And let's name it STL.cpp. Now we'll add the header files. Now writing namespace standard. Now we will add, before namespace standard, we have to add the header file for vectors, because we are doing the example of vector, so that is why we have to add the header file of vector. Okay, now we'll write int main. Now first of all we'll declare the vector. So we'll write vector int within the angle brackets. Now we will write the name of the vector, that is v. Okay, now we have to push some elements inside the vector. For that we have to use for loop. So we'll write for keyword int I equals, let's say 1, I less than equals 10, I plus plus, that is increment operator. Okay, now we have to push the elements one by one, so we'll write v dot push back, and inside the bracket we'll put I. So the elements will keep on adding one by one at the end of the vector. So now we will check the size of the vector. So we'll write the message size and then the function v dot size. It will tell us the size of the vector, that is the number of elements inside it. As we can see that we have put 10 elements inside the vector one by one, so it must be 10. So in order to check it, we have used this function v dot size. Okay, now we'll use another function, that is v dot resize. It will resize the size of the vector. So whatever we put inside this bracket, like let's say I've put 7, so its size now would be 7. And we need to check this also. So we'll again use the function size. So first of all we'll display the message. After resizing, it becomes v dot size. It will print the size of the vector after resizing. Okay, Now we use another function v.empty. For that we have to use if condition. So we'll write v.empty brackets. We know that if v.empty equals true, then it means it is empty, and if it equals false, then it means it is not empty. So we'll simply display the message that it is not empty. We'll write cout, and now we'll write with /n not empty. We forgot to write the commas over here. Okay. Now in else we will write it is empty. It is empty. We can also do this the other way around, like we can put v.empty equals to true, and then inside that bracket we can write it is empty, but it's your choice. Okay, now we'll display the elements of the vector. For that we have to first write the message. So we'll write elements of vector. Then after this, using for loop and iterator, we will print those elements. So let's do this. We'll write for, and inside for loop we'll write auto it. Here the auto keyword specifies the type of variable that is being declared will be automatically deducted from the initializer, and it is the iterator. Now we'll write it equals v.begin, and we know that v.begin function will point to the first element of the vector. So after that we'll write it not equal to v.end, and it will point to the last element of the vector. Now we'll write it plus plus. Now we'll print the iterator using dereference operator, and in order to make some space we'll write this. Now we return 0. Okay, now let's try to run this. Okay, here is the problem, I think. Now let's try one another time. Here it is, size 10. After that, after resizing, it becomes 7. Firstly, we add the elements by pushing one by one using the pushback function. 10 elements were added, so size is 10. After that we have resized it, so after resizing it becomes 7, and then we have used the function empty. So it was not empty, so that is why the message displays not empty. Then the elements of vector, I forgot to put space over here, and elements of vector 1 2 3 4 5 6 7, and that is correct. Okay, now we'll do one example of iterator. In this example we'll simply print the elements of a vector using iterator. So first of all, let's name this stl2.cpp. Now we'll write the header files, hash include IOStream. In this we'll add 3 header files. Now we'll write hash include iterator, because we have to use iterator, so that is why we are doing this. And we also have to use the vectors, so we'll write hash include vector. Now we'll write namespace standard. Now we'll start with int main. So first of all, we'll declare a vector in which there are some elements. As in previous question, we already learned how to add elements in a vector. So in this question, we'll simply declare those elements inside a vector. So we'll write vector int inside the angle brackets. Now let's say AR is the name of this vector. Now we'll write the elements. Five elements are there. Now we have to declare iterator to a vector. So this is how we'll do it. We'll write vector, then the data type inside the angle brackets. Then after this we'll write the scope resolution operator like this. Now iterator keyword, then the name of the iterator, that is PTR. Now we'll display the vector elements using for loop and using the functions begin and end. So we'll write, first of all we have to display a message. Okay, we'll write the elements of vector are. Okay, now semicolon. Now using for loop, we'll write the PTR, that is the iterator, AR dot begin. As we know that AR is the name of the vector. AR dot begin. Begin function will point to the first element of the vector. Then PTR less than AR dot end. We know end function will point to the last element of the vector. Okay, now we'll write AR plus plus. Sorry, PTR plus plus. Now we have to display it, and we'll display it using dereference operator and the name of iterator, that is PTR. We'll make some space. Now at last we'll write return 0. Now let's try to run this. The elements of vector are, as you can see, the elements of vector are 1, 2, 3, 4, 5. So this is how you can print the elements of a vector using the iterator. Here is the vector, and with the help of iterator we have printed these elements 1, 2, 3, 4, 5. Now we'll do one simple example of algorithm. First of all, let's name this STL3.cpp. Now in this example we'll use swap algorithm to swap two integers, and we know that swap is a template function. So let's do this. First of all, we'll write hash include IOStream. Now using namespace standard, we'll start with int main. Now first of all we declare a variable, let's say 7, and second variable, let's say 10. First of all we'll display the value of these variables, that before swapping and after swapping. So that is where we'll write value of I. Now here we'll write value of j. And L. Okay, now we'll use the swap algorithm, and here we'll mention the elements we want to swap, I, j. It will simply swap the contents of these two elements. Now we'll write after swapping. And L. We'll do same for j. This is a very basic example, but we have to see the functionality of it. We'll write and L. Okay, now we'll write return 0. Now we'll run this. Yeah, value of I 7, value of j is 10. After swapping I 10, j 7. It will look better if we have wrote like this. Let's make it look good. Yeah, value of I is 7, value of j is 10. After swapping, I becomes 10 and j becomes 7. So this is how we can swap the elements using swap algorithm. There are some more algorithms, you can try those as well. And now at last we'll do one example of function object. Let's name this as STL4.cpp. Alright, now we'll add the header file. Hash include iostream. Now we'll write namespace standard. Now in this question, first of all we'll start with the function. So first of all we'll make a class function obj. Now we'll write access specifier public int. Here we'll write the call operator. As we know the syntax, operator bracket, then another bracket for the arguments, int x comma int y. So this is the syntax of it. And now whatever we want to do with these two variables, let's say we want to multiply, so we'll write return x into y. Alright, as this is a class, so we have to write the semicolon. Now we'll write int main. Okay, now we'll write int main. After int main, here we'll write the name of the class, because we have to define the object of it. Now the object is FO. So here class name is function obj and its object is FO, and as I have explained earlier, here I can use FO object like a normal function because FO is the object of class function obj in which call operator is defined. So it will act like a normal function. So now we'll make a variable, let's say multiply. So we'll write mult equals FO, and because it acts like a normal function, so we'll pass the parameters 4 and 7. Now in order to display, we'll write cout and we'll write multiplication of x and y is, now we'll write the name of the variable mult because the result is getting stored in mult variable. Now we'll write return 0. Now let's try to run this. Here we can see multiplication of x and y is 28, and that is true. 4 into 7 equals 28. So it is working, and this is the example of functor or function object. So these were some basic examples of components of STL. You can practice some more examples on them in order to learn. In this video we will learn about C++ enumeration. So let's go ahead and have a look at what we'll be covering today. First is why enumerations are used in C++. Then we'll understand what is enumeration and its syntax, and after that we will learn how to use enums with flags. First is why enums are used in C++. Enums are short for enumerations. These are basically used when we have some set of possible values and we have to select one out of it. For example, suppose you are the shop owner and you have 4 types of coffee in your coffee machine. That is cold coffee, hot coffee, black coffee and mocha. And you don't want the trouble of customer putting any other coffee name in the machine which is not there. Then in situations like these, enumerations are used. Because in enumerations we have to choose from predefined values, and it is also helpful for documentation and readability purpose. Now let's understand what is enumeration. Enum or enumeration is a user-defined data type in which a set of values are specified for the variable, and the variable can take out any value from the set of values. And it is also a way to use integers to represent values. We can assign values to enum, but if we do not assign any value, then the compiler assigns value to them starting from 0. Coming to its syntax, which is enum, that is the keyword for enumerated type, then enumerated type name is written, then under brackets possible values of type enum are written. For example, here enumeration name is player and values are Ronaldo, Salah, Messi, Neymar, which are the names of players. In this example, by default, Ronaldo is 0, Salah is 1, Messi is 2, and Neymar is 3. Because we know by default compiler assigns them value which start from 0 and so on. But we can change these default values by assigning values to them. Like here, Ronaldo's value is now 4, Salah's value is 2, Messi's value is 8, Neymar's value is 1. Now, let's have a look at an example in which we will print the default value of months. So in this example, we have enum name as months and enumerated values as January, February, March and so on. And in order to access these values, we have written enumeration name and after that the variable. As we can see inside main function, m is the variable and its type is months. Now here we have assigned the month March to the variable m, and then we are printing the variable m plus 1. Here plus 1 will print the value next to the month March, that is 3, and similarly if we write plus 2, then it will print the one next to it, that is 4. These values are default integer values. After printing the output, value is 3 because we have printed m plus 1 where m is 2 and plus 1 makes it 3. Now let's understand how to use enum with flags. In this example, we will choose a mobile having any of the two features among three. Here the name of enumeration is mobile and its enumerated values are battery capacity, camera quality, large storage, and we have assigned values to them 1, 2 and 4 respectively. And because we are doing this example of enums with flags, that is why we are using integer values of power 2, because it avoids the overlapping. Inside the main function we are using bitwise OR operator because we want to choose the mobile having both camera quality and large storage capacity. And we know that bitwise operator adds the binary of two integers. So the value of camera quality is 2 and value of large storage is 4. When we use a bitwise OR operator in between these two features, so it will add up their binary giving the decimal number as 6. So the output 6 is showing both the camera quality and large storage are used. Now let's do some examples of enumeration in our code editor, that is VS Code. Okay, now let's make a new file and name the file as enum.cpp. In this example, the enumeration name will be captain and the enumerated values will be the team members, out of which we will select one member as captain. And with if condition, we will verify if he is the selected captain or not. It will be a basic example. So first of all, let's write hash include iostream. Now we'll add the namespace standard. Okay, now we'll write enumeration enum captain, which is the name of the enumeration type, and now we will write the enumerated values, which is let's say Avi, Sid, Robbie, Sammy and Jake. These are the team members. Now we'll write int main. Now here we will first of all write captain, which is the name of the enumerated type. Then we'll make the variable out of it, cap. And let's say Avi is the captain. So we'll write Avi. Now here we will write if condition. We'll write if cap equal to Avi. Then we'll display our captain is Avi and its value is whatever the value. Avi's value here is 0, so we'll display that. So we'll write our captain is Avi and its value is, then we'll write Avi. As we know that Avi is at first position, then its value would be, default value would be 0. Okay, so here we will write endl. Now in else, here if we put Sid, Robbie, Sammy, Jake as captain, or if we declare them as captain, then this message would be declared, which we will be writing in else. So the message would be he is not our captain. Then over here we will write return 0. Okay, now let's try to run this. Our captain is Avi and its value is 0. Because here captain we have declared Avi, so that is why this is printing. If we write, let's say, Sammy over here, then it will print the else part. He is not our captain. And if we write Jake or Sid, then also it will print the same. He is not our captain. Only in case of Avi, it will print our captain is Avi and its value is Avi's value. So this was the basic example of enumeration. Now let's move on to another example. Now let's make a new file and name it as enum2.cpp. Okay, now we will add the header files #include iostream and using namespace standard. So here we will do an example in which enumeration name will be supercars, and to the values we will assign some integers to them, which will be the speed of those cars, and then we will compare them using comparison operator in terms of speed. So we will write enum, then name of enumeration, that is, let's say, supercars. Okay, now inside the bracket we'll write the name of the cars, which are the values, and we will assign some integers. These integers are actually speed of these cars. $268, then Valkyrie, speed is 240. Now Roadster 250. Okay, now as we have created the enum, now we will start with int main. So we will write the enumerated type name supercars. Now the variable speed 1, because we want to create two variables in order to compare them. So first we will create speed 1. Now again speed 2. Now we will assign the two cars that we want to compare to these variables. So speed 1 will be Valkyrie, and speed 2 would be Roadster. Okay, now we will write the if condition, and inside the if condition we will compare the speed of these two cars. So we will write speed 1. If speed 1 is less than speed 2, okay, then we will print that it's a win for Roadster, because speed 2 is Roadster and speed 1 is Valkyrie. So we'll write it's a win for Roadster. With the speed, we'll also write the speed with the speed of this speed 2 will display the speed of Roadster, that is 250. Okay, now else condition. So here we will write it's a win for Valkyrie. With the speed of Here we will write speed1. Okay. Now we have to write int main, but before that we will write the bracket which we forgot to mention. Return 0. Okay, I think it's done. Now let's try to run this. Here we can see it's a win for Roadster with the speed of 250. As we know that the speed of Roadster here is 250 and the Valkyrie speed is 240. So when we compare it, speed 2, that is Roadster, wins because Roadster is 250. So this was the second example. Now let's do one last example. Let's name this. Okay. enum3.cpp. We'll write hash include iostream. Now namespace standard. Now in this example we will see how to use switch statement with the enumeration. Okay, so first of all, inside int main we will write enum. Color is the name of the enumeration type. Then we'll write the values: red, blue, green and yellow. These are the values. Now here we will use switch statement, but before doing that we have to assign one color to a variable. So first of all we have to create that variable, and in order to create the variable we will write the enumeration type name color and then the variable name select. Now we will assign one color from the above colors. Let's say yellow. Now in switch statement we will write, first of all we will write switch statement, switch, and we will pass here the variable, that is select. Basically we are passing yellow because yellow is assigned to the variable select, and that is why it is getting passed. So now case 1, that is case red. First of all we'll write the case red with a colon in the end. Now we will print that it is red. Now we'll write the break statement. Break statement basically ends the case or terminates the case. So after that, the second case, that is case blue, colon. Now here we will print it is blue, and similarly break statement. We'll do same for all of these colors, green and yellow also. And switch statement will help us to find which color is passed and will display the message of that color. So here we will write green, it is green, break statement. Now case yellow, now we'll write it is yellow. Now here we'll write break. Okay, now at last we have to write return 0. Now as we know that we have passed a particular color to the variable select, and select is the expression, and switch statement will help us in comparing the variable select value to the value of different blocks, and one which matches that particular block will execute. Okay, now let's try to run this one. Here we can see it is yellow is being printed, which is the right answer because we have passed the color yellow to the select, and that is why only the case yellow output is being printed. So this is how you can use switch statement with the enumeration. So these were some basic examples of C++ enumeration. You can try some more examples on it in order to practice it.
And that brings us to the end of today's session, guys. I hope you all have understood all the topics and concepts covered in today's session. Thank you for watching the video, guys, and sticking with us throughout this session. If you found this tutorial informative and helpful, give it a thumbs up and make sure to share it with your friends and colleagues. And most importantly, don't forget to subscribe to our channel SimpliCode for more such amazing content on various technologies and programming languages. If you have any further queries regarding any of the topics covered in today's session, feel free to let us know in the comment section below, and a team of experts will be more than happy to help resolve all your queries at the earliest. Make sure to check out the part 1 of this C++ training program series on our channel so that you'll have a better idea. And also stay tuned for the final part of this training program series on C++, wherein we'll be covering some more advanced level topics and discuss some of the projects that are related to C++ that a beginner can start with. We have a similar training program series on various such technologies like JavaScript, Java, and SQL on our channel as well. So make sure to check that out as well, and we'll leave all the links in the description below. Until next time, stay safe and keep coding.